Won't you João, eu vi que estava aí o Vasco. Não sei se tu me ouves. Exato.
Ouço,
Não sei se
ouço,
Vasco.
ouço sim, ouço sim. Sim, já aqui está o Vasco. Queres que eu envie já para aqui? Ou só a
O
partir
Vasco,
das
sim,
duas?
podes pôr, mas só o Vasco. Depois,
Ok,
sim,
está
só
bem,
o Vasco, mas
está bem, está
sim.
bem, está bem.
Tá bem?
Ok, estou a aceitá-lo. Portanto, ele já aparece aí, está bem.
Ok, boa, boa. Boa. Olá, Vasco.
Oh, tudo bem?
Tudo? Então.
Estamos aqui com uma crise de internet no coworking. Já voltou.
Floriano. Convém.
Voltou
Hoje,
agora mesmo, neste segundo.
olha, eu até tenho aqui uma internet móvel, just in case. Não, a sério, porque às vezes a minha internet fica lenta e não pode.
Epá, pois eu também já estava aqui com
É,
isso, com a internet de telemóvel.
é. Hum, Olha, dá-me só um segundo. Vou buscar água e coisas. A casa
Ah,
bem. Bem, tudo bom. Hum, Abrimos já para as outras, para as pessoas que estão a juntar.
sim, sim.
Força, João.
Ok.
Olá, boa tarde.
Olá, Jorge.
Boa tarde.
Boa tarde.
Boa tarde, tudo bem?
Boa tarde.
Boa tarde.
Boa tarde.
I see that there's more people joining, so let's start in 1 minute. Okay.
Sorry to interrupt, Margarida. I think Stefan was moved here accidentally. Oh no, he's back. Never mind.
Okay. I'm going to start by sharing my screen. Okay. Can you all see my screen?
Yes.
Yes.
Okay, great. So welcome to the online pitch of the renewable energy and green hydrogen track. This is the first day. Tomorrow will be the second one. And let's see what we have. I'm just going to do a very short presentation and then we're going to go to the first pitch. So I'm just going to go through the timeline, the structure of the pitches, the lineup for today, and the job to be done. Regarding the timeline, so as you know, we are in the online pitch phase. Today is day 1, and tomorrow will be day 2. Tomorrow we're gonna do the pitches in the morning, Lisbon time. And the purpose of this phase is to select the startups for the bootcamp, which will be from the 15th until the 18th of April here in Singapore. And regarding the structure of the session, so we have 10-minute slots per startup. So 4 minutes for them to pitch, 4 minutes for Q&A, and a buffer of 2 minutes, just to make sure we are on time. Regarding the lineup for today, so we have all these 20 startups. We're going to have some breaks. I'll let you know when we have those breaks, 10 minutes breaks. And we'll be closing the session by 6 p.m. Lisbon time. So Okay, this is for tomorrow regarding the job to be done. So you will be evaluating the startups, right? And please take into account the team, the novelty of the solution or product, also the business model and the fit it can have with EDP, and also the pilot's readiness. So past use cases they've done. Also use the Q&A to ask the questions, or you can also raise your hands there in the chat. And always think about a possible pilot to be developed between you and the startup, and ask for information on that regarding that, the viability of a possible pilot. Yeah, so that's it. And we can already go to the first startup.
Margarita, sorry.
Okay.
Just to add, I've shared with all of you the Excel file where you can leave your feedback regarding each of the startups. The same as in the applications phase, I've created a tab for each of the teams present here today. So you feel free to leave the feedback in real time, or you'll have a couple of days also to tell us which ones you'll like to have follow-up meetings with. So the ones that you have the most interest in getting to know better with their solutions, and yeah. So thank you very much, everyone, for joining today, and please don't feel shy to ask questions during the pitches.
Yeah, so let's go for this. So the first startup, it's Tsubame BHB, and Tomoyuki will be the speaker. So João, you can let Tomoyuki in.
Hello.
Hello. Hi. Hi,
Hi.
Tomoyuki. So we are here welcome to the Energy Starter. We are here with EDP, and we're ready to hear your pitch. So go ahead. You can share your screen, and you have 4 minutes to pitch.
Okay, can you see my screen now, right?
Yeah.
Okay. Hi, everybody. This is Tomoyuki Koide from Tsubame BHP. And then our solution is a clean and distributed ammonia production by our novel catalyst technology. And we are a Japanese startup company. And then first of all, so I'm talking about the ammonia. So ammonia is currently produced 180 million tons, and the 80% is for fertilizer. So ammonia is essential for the agriculture. Not only for that, ammonia will be used for clean fuel or like a hydrogen carrier. So ammonia is quite important to achieve the decarbonization in future. However, the problem of ammonia is currently 500 million tons of CO2 is emitted by current ammonia production. So here is our technology, which is catalyst technology developed by the Tokyo Institute of Technology, which is a university in Japan. And then the catalyst, which is called electrolyte catalyst, which enables lower temperature, lower pressure ammonia synthesis. And this catalyst containing electron inside, and then this electron works as a scissors to cutting this nitrogen's bonding for ammonia production, then which is much lower pressure and temperature ammonia production compared with conventional technology Haber-Bosch process. And then this is advantage for the small scale production. So we developed a small scale ammonia production system. Here is our achievement so far. So our company established in 2017, and then we focused on the scale up of the catalyst manufacturing. And then once catalyst is ready, we constructed a pilot plant, and then this pilot plant started the operation from 2020, so which is running more than 4 years in Kawasaki, Japan. And then we already received a small ammonia plant, commercial plant, which is we call it fast commercial plant order. And then we are executing this EPC for this fast project. And then this plant will start operation in 2025. And then so far, we had several financial round already, and then we raised more than $50 million US so far. That's our company's status. And then this is our proposal for the jointly developed pilot project together with EDP. So green ammonia project, from now on, it's very important to produce the ammonia without CO2 emissions. So green ammonia production is quite important, we think. And then EDP is developing the renewable energy as well as developing the green hydrogen production. And then we'd like to use that one for the source for this our small-scale ammonia production system. Small-scale ammonia production system, we have three lineups, 500, 3,000, 5,000. And then this number is equivalent to like a ton per year of the ammonia plant production capacity. So basically, it's very small-scale unit. And then our concept is a distributed small-scale ammonia production. And then we want to achieve this green ammonia pilot project together with the EDP. The purpose is, there's two purposes. One is establish the method how to manage the fluctuation of the renewable energy, such as solar and wind power, and also to trying to evaluate the feasibility of these kind of green ammonia projects in various locations. So what we want to do in the next phase is trying to first of all, we need to understand the EDP's green hydrogen strategy, and then what's your status, and what's your target of the cost of the hydrogen production. And then based on that, we'd like to jointly evaluate the business cases of the green ammonia production utilizing our Tsubame's ammonia production technology. And then finally, we'd like to scope the target of the green ammonia off-taker together. So that's what we are thinking about to do together. That's the end of my presentation. Thank you.
Thank you for respecting the time.
Yep.
Okay, so now we can go for Q&A. Who here has questions? You can both write in the chat or you can raise your hand.
My screen is frozen, but I have a question if you can hear me. Sorry. Can I do the question?
We can. Yeah, go ahead.
Yeah. My question is, comparing to traditional production of ammonia, what is the main advantage here? It's the efficiency of the production, and how does this translate in terms of economic savings, in terms of energy spent per ton of ammonia produced? Can you give some light on that? And also,
yeah, sure.
how much would be the capex for such a pilot as well?
Yeah, so basically the difference of this technology is a catalyst, and then the catalyst enables a lower pressure, lower temperature ammonia reaction, and then which will be basically for the advantage on the capex side of the system, especially in the small scale sites, because there like a much lower design temperature and pressure, which is much easier to manufacture in the small scale. That's main advantage on the capex side. And answering to your questions, a very roughly image of the cost for this kind of ammonia system will be like for example, like a TM3000, which is a 3,000 ton per year production system, which is very roughly like a maximum 10 million US dollars level. So here is our like image of the cost.
You said 2 million?
10 million.
Okay, for 3,000 tons, right?
Yes, yes.
Okay, thank you.
Okay, someone else?
Yes, just to complement on the question of Pedro, what is the efficiency of your solution compared to the traditional method?
Efficiency means so efficiency can be the like utility consumption is one of the like parameter to evaluate, and then which will be actually equivalent level compared with Haber-Bosch versus ours.
So equivalent. So you estimate to be the main advantage would be the operational conditions at lower temperature and pressure, and the capex advantage would be the differentiating factors, right?
Yes, yes. Okay, one point I need to mention is if there's like a very big scale Haber-Bosch plant, and then which is already like a well improved and very good efficiency already there. So which is difficult to compete with such a like a large scale one versus small scale one. However, if we are in the same size, same capacity size, and the Haber-Bosch and the Tsubame's technology, then we have much advantage on the, especially on the capex side.
Understood. And you said that your technology is differential because of the catalyst. So you produce only the catalyst, or you also would be responsible for the integration and the assembly of all the facilities in this proposed pilot?
Yeah, so regarding this modular system, Tsubame is responsible, and then we have lots of like a vendor network, and then those kind of vendor will manufacture these kind of like a components, and then we will assemble and then trying to install. And then Catalyst itself, of course, it's our like own IP, so we manufacture and then deliver to the site and then install into the system.
Understood. You have any proposed geography, or you are agnostic in terms for this pilot? You are open for proposals?
Yeah, we are open. We are trying. Yeah, any location is fine for us.
Okay, thank you.
Philip, I believe you have a question, right?
Yeah. I don't know if you have already made some calculations and understand what is the price of hydrogen that you need right now to become competitive with this solution? Do you have any estimations on that?
Yeah, so basically, so considering about the current ammonia market price, so based on my calculation, required price of the renewable energy is like 30 or 40 megawatt, 30 or 40 US dollar per megawatt hour is needed to compete with current market price of ammonia. However, this ammonia, green ammonia, I believe and I hope there should be some like a premium value on top of current gray ammonia. So if there's any additional value, then we can be much, we can get much more profitable. But that's my understanding of the like threshold of the required renewable energy.
Okay. And you said in the beginning that the main utilization of this ammonia is for fertilizer, which I understand. Have you spoken with some fertilizer producers to address their interest on paying a premium for this green ammonia?
Unfortunately, fertilizer people, they don't care about like a gray or green, so they don't feel much premium at this moment.
Okay. Thank you.
Okay. Thank you. Thank you. Thank you for the presentation, for the pitch. We'll let you know the results in the next few weeks, and yeah, have a great day. Thank you.
Thank you. Bye.
Bye. Okay. So, yeah. Next, we have Stefan from Sweetch Energy.
Hello, everyone. Good afternoon.
Hi, Stefan. Welcome.
Thank you.
Welcome. So we are here with DDP, and okay, perfect. We see your screen,
Perfect.
and so you have 4 minutes to pitch, and then we go for the Q&A. Okay?
Perfect. Thanks a lot. So I'm Stéphane Chariot. I'm the head of global business development for Sweetch Energy, which is a French startup based in the west of France. Looking at the current power generation mix worldwide, we see that still 60% of the generation is coming from fossil fuels. And in the meantime, we understand from forecasts that the electricity demand will probably double by 2050, which is a challenge for the net zero emission target in 2050. The addition of solar and wind capacity by 2050 will only compensate the increase of electricity, and it means that fossil fuel will remain at the same level. So therefore, we consider in Sweetch Energy that there is a need for a new renewable energy source if we want to reach this net zero 2050 objective. And this is why we developed a solution to harness the osmotic energy. So the osmotic power is the energy which is released as soon as we mix 2 streams of water with different salinity concentrations. So in the nature, in the deltas and estuary, as soon as the river mix with ocean, there is a release of osmotic energy. 30,000 terawatt per hour per year. This is a quantity of energy which is released every year in all deltas and estuaries worldwide. This is more than the electricity consumption, which is around 27 terawatt per hour per year. So Sweetch Energy developed the INOD technology, INOD standing for Ionic Nano Osmotic Diffusion, to harness this potential. This technology is made with a highly selective membrane, which allows only the transfer of salt ion from the seawater to the freshwater, accelerating the transfer of salt ion, generating ionic currents that we can then convert to electricity with the use of electrons. So this is here a typical installation of an osmotic power plant. We have on the right side of the slide here the river, and we have a water intake for fresh water. On this side, we have a water intake for seawater. We have the discharge of the two flows of water in the sea after use. Absolutely no impact on the environment. We only mix seawater and freshwater. There is absolutely no addition of any chemicals. And then we have two buildings, one for pumping and filtration to bring the water and filtrate the water. And then we have a second building here in which we have the osmotic generators. As you can see here on the picture, we define the number of osmotic generators based on the quantity of fresh water which is available. So as you can understand, this technology is of course fully renewable. There is absolutely no emission. This is still abundant. We have a lot of water, fresh water available worldwide. This is highly modular, which provides a lot of flexibility. And the beauty of this technology is that we have a permanent generation of electricity. So of course we can use it as base load. We have done a complete assessment of 11,000 locations where seawater and freshwater mix. So we know exactly what we can extract and where. And typically looking at the countries where EDP is very, very active, we see that we have a potential of 17 gigawatt in the US, 15 in Brazil, a bit less than 1 gigawatt in Europe, which is a huge potential, generating 260 million of megawatt per hour per year of electricity, clean electricity, permanent electricity. So what do we want to do with EDP? Typically, we could move forward with the first pilot. This is what we would like to have. Could be done on the Tagus River in Lisbon, where there is a potential of 77 megawatts. We could start with let's say few hundred kilowatts, as this is very modular. We can start with a very, very small installation and progressively add additional modules to reach the final capacity of the power plant.
Thank you. Thank you, Stefan. Now we're going to go for Q&A. Okay, so who here has questions for Stefan?
Well, I can make a question. Can you hear me, Margarida? Yeah.
Yes.
So, Stefan, thanks for your presentation. Regarding the TRL of the technology, do you have any pilot in place already, or have you tested this technology anywhere?
We are currently building the first pilot in the south of France, where we have a JV with CNR, the Compagnie Nationale du Rhône, which is a subsidiary of ENGIE. We've started work at site 2 weeks ago. The first osmotic generators will be delivered by the end of June and put almost immediately in operation. And we will reach the final size of the pilot by the end of September this year.
Okay, and what's the size of this pilot, you said?
It's going to be up to 50 kilowatt, a small installation. It's not going to be connected to the grid. It's going to be, the electricity will be consumed by a lock. We are going to install it on a lock. On one side of the lock, we have fresh water. On the other side, we have seawater. And electricity consumed by the lock. So this is also why we remain with a small capacity, but at the end of the day, we'll have several hundreds of modules installed on this pilot, so we can also demonstrate the flexibility of the operation with this kind of technology.
Okay, and regarding costs, the capex and the opex of these systems, what's the figures for them?
Well, this is clearly capex driven, to be completely transparent. We have some water intake, we have some installation, and also because for the time being we manufacture our module manually, so it has a cost. Starting from 2025, we'll have a first production line, fully automated production line in France, and the cost will drop down. For the timing, for the first installation, we have a cost of energy which is going to be between 150 and 180 euros per megawatt per hour. So we are on the high side. But as soon as we will have this first production line fully automatized, cost will drop down, and we expect to have an LCOE around 120. And on long-term basis, within 10 years, because we are only at the beginning of the story of osmotic energy, we expect to be at 50, 60 euros per megawatt per hour, which is, at the end of the day, the same trend as we saw for solar. Solar was at 200 euros per megawatt per hour 10 years ago. We expect to have exactly the same trend, but with a permanent generation of electricity.
Okay, thank you.
A quick question on just on the impact of the cost of not having, because on most of the cases you don't have the fresh water and seawater side by side. What is the impact for sourcing fresh water if you have to go several kilometers for sure upstream?
Well, the target is not to collect fresh water a few kilometers, because of course it will have an impact on the efficiency of the system. Target is to be as close as possible to the two streams of water, and typically this is what we see on the picture with the tagus. You have also to know that due to the difference of density of the water, usually in large deltas and estuary, we have a layer of fresh water on top of seawater. So at the end of the day, if we position correctly the water intake, we can collect the fresh water on the top of the seawater. So we minimize the distance for the water intake.
Did that answer your question, Andre?
Yeah, I think there's some questions in the chat. So
we have one here from Wish. Could you give us an idea of how much water you need to move to produce 1 million? Sorry, how much?
1 million
watts.
Yeah, to make it short and very, very simple, this is not really exact as an answer, but just to have 1 megawatt power plant, we need 1.5 cubic meter per second of seawater and 1.5 cubic meter per second of fresh water, more or less. This is not really exact, but this is the rough figure.
Okay, and just last question. Do you have an idea of net capacity factor of such a plant like this in Lisbon?
Not yet, because it has to be studied. What I can tell you for the pilot, as soon as we will be over 20 kilowatt, we are going to exceed 50% net power output. So then if we continue to add some modules with the same installation, we will increase the ratio.
Okay. Okay, now the real last one. Andres, go ahead.
Yeah, what are the main environmental impacts that you see from this solution?
Well, I would say nothing. Of course, we have to do some environmental studies for all projects that we develop. But at the end of the day, we only take fresh water, seawater from the river and from the sea. And then we mix both water and without any addition of chemicals. So no addition of chemicals. There is no change of the temperature. We do not increase the temperature of the water. And we release exactly the same quantity of water and the same quantity of salt. So at the end of the day, more or less no impact.
Okay, thank you.
Okay, that's it. So Stefan, thank you so much for your pitch, for your presentation, and for answering the questions. And we'll get back to you in the next few weeks with the results.
Thanks to all of you. Thank you. Thanks for your time.
Thank you. Okay, so next on the schedules we had Novos Erto operations, but they dropped out. They are not coming to the pitch. So we are going to go to the next one, which is GA drilling. We're going to have Igor presenting. So João, you can let Igor in.
Yes, hello. My name is Igor. I'm from GA Drilling Company.
Hello,
Igor. Presentation?
Yeah, we can. Welcome. Welcome. We are here with EDP and we're ready to hear your speed or your pitch. So go ahead. You have 4 minutes to present and then we're going to go for Q&A. So go ahead.
Yeah, perfect. So my name is Igor Kosis from GA Drilling. And what we are bringing the missing piece of the renewable energy mix that we analyzed. We came to clear conclusion that the only geothermal as a power source is able to fill this gap between the solar, wind, and the other renewables that can deliver the energy in a scale globally. And first, what does it mean, the geothermal energy? And it is the, let's say, big battery that we are sitting on. And this battery can work for billions of the years to power the mankind. But unfortunately, today, we are not able to use it efficiently. And the problem is that, as you know, from Iceland, from other territories that are sitting on volcanoes, that you can do hundreds of megawatts from this source. But in 97% of the area globally, you are not able to do it economically. It means that for the same power and temperature, you have to drill much deeper and not able to do it economically viable way. And what is the problem here is that you need to totally change the paradigm of the drilling and of the cost of the whole system, because drilling deeper means today that the cost is rocketing exponentially, and therefore the deep geothermal projects are super expensive. What we are doing and what's the challenge is to develop the solution and drilling technology that is able to overcome it and to make the drilling feasible. So what we achieved, we worked for several years intensively, invested a lot of money, effort to develop advanced technologies that are using both mechanical ways of the drilling, but also so-called thermal drilling, when you are using plasma. Not going to details, you can imagine as a Star Wars sword that can go much faster through the rocks than the mechanical metallic or diamond. And we can achieve much higher parameters. We already achieved good success in testing. And here what you see regarding the potential, we are first bringing existing projects deeper. It means to the depths that are 5 to 6 kilometers. Then you can generate then tens of megawatts from the projects. And each step-by-step learning curve and technology advances in the next years, we are able to expand the geothermal from approximately 3% of the area. There's the same map, same situation in the map that is today suitable for geothermal, and expand in the next years, 25 and 27 and 29 to the areas wherever. And our view of the potential pilot is exactly in the areas that you see in the first or second slide, to expand it also when it's not feasible today. And what we are proposing as a pilot is to have a deep geothermal system that is focused to deliver tens of megawatts of the power, and being able to get 200, 250 Celsius, like you know from the Iceland or some specific territories, but to do it where you need it, not to the places that are only naturally suitable for that. And here we see the three practical potential pilots with the EDP. We studied in depth these areas that, first of all, are the new geothermal projects that could be built nearby the solar and wind current installations, and it can bring the strong value in the baseload capacity. Second, it could be replacement or cogeneration of existing heat supplies. It means with the geothermal power, you can directly use the steam for the heating for thousands and thousands of the households. And last is retrofitting, is a big scale electricity focused project, retrofit the gas and coal sources. Last point, the example that, for example, we looked for your EDP assets in the States. Some of them are in really great geothermal potential areas, and building such kind of the geothermal system nearby your assets, it can totally help with the grid balancing and with delivering energy 24/7. So finally, what we are offering with the geothermal is access together with EDP for the clean baseload power that is most resilient source from the perspective of the safety, and is distributed, and what is most important, you can build it anywhere. So happy to answer your further questions.
Thank you, Igor. Thank you. Let's go for the Q&A. Who here has questions?
I can make a question then. Hi, Igor. Thanks for your presentation. My question is simple. I think is just from those pilots that you proposed, is there anyone that you would prefer, and any geography that you would prefer also, where you are already located, or you are agnostic to that?
First answer is that we are quite agnostic from perspective of the territory. Of course, we are preferring something that will be nearby in Europe or in the States, not in some very distant area. And specifically, low-hanging fruit for the geothermal is the heating. So first, you can produce a very fast way the steam, and then also expanding the power to generate the electricity. So we see there's some step-by-step approach. Ideal project would be when we can start with the heat delivery, and then to, let's call it, upgrade it into the electrical power.
Okay, thank you.
Okay.
Good. Any other?
I have a question, quick one. How certain or how uncertain is the cost of drilling a well 10 kilometers deep? And how sure can one be of the total cost of the drilling before doing the drill?
It's a very good point, because this is exactly the biggest problem we are solving. That this is not only about the cost, it's about the risk that you just addressed. Here for us, what is key is that currently we started last year to successfully show and present also publicly our system, how it can help with these drilling projects, exactly to be much more deterministic. It means in a to translate it into the parameters that you are drilling basically with a constant speed and almost constant price per meter. And if you are able to achieve this parameter, you can then plan the projects in a deeper depths. Today, the situation is opposite. Going deeper means that costs can easily rocket it like 2-3 times as you prefer. And in the way that you are predictable, able to say clearly that how much does it cost 1 kilometer is much less dependent on the geology and on some uncertainties that we can meet. So this will be also some learning curve that is also in the drilling business in the past documentable, like for example, was a shale gas in the United States. Just by the scale and the learning curve, they're able to cut their costs in another 50 to 70%. So this is also our view. Once we are able to achieve some campaign mode, not to do the isolated one project, that definitely your cost will be not only significantly cut, but it will be also de-risked.
Okay, someone else? Okay, I think we're very clear, Igor. So no more questions? Yeah. So thank you for your presentation. I'll let you know the results in the next few weeks. And that's it. Have a great day. Thank you.
Thank you. Appreciate the question. If anything more, just let us know. Thank you. See you soon.
Thank you.
See you. Okay. So next we have QHeat, and we're going to have both Erica and Rami. Joe, you can let them in. Hello, Erica.
Hello.
Hi. And Rami, hi.
Hello.
Welcome. We are here with EDP, and we are ready to hear your pitch. So go ahead, share your screen, and you have 4 minutes to present. Okay.
Great. Oh, let's see.
Yeah, you can see.
You can see.
Yeah.
Good. Okay, so I'm Erica from QHeat, the CEO and co-founder. Together with me, I have Rami, our original founder and CTO. Thank you for the opportunity to present QHeat. We see a growing interest in geothermal, and I feel that within the next 5 years, we'll see new ideas and achievements, but we'll also see that geothermal will grow its share in the energy market. And solar and wind required many years of hard work before they became profitable energy sources. Geothermal is on the same path, but has a big advantage as it provides continuous 24/7 energy that doesn't depend on weather. My pitch focuses on geothermal as a heating and cooling solution. In Finland, where I'm located, we drilled our first geothermal heating plants in the 90s. And back then, it wasn't profitable, but it made sense for those who crave clean and self-sufficient heating. And today, ground source heat pump solutions are the most common heating solutions in detached houses. More than 50% of new detached houses pick ground source heat pumps as their solution in Finland. We haven't had a single project that would focus on power generation because our bedrock is nor permeable, nor has it any hot spots. But more than 50% of our energy demand is from heating. And by the way, the number is the same globally, not only in the cold Nordics. I describe this process to you because it has a lot to do with QHeat. Unfortunately, traditional ground source heat pumps require a lot of land use. One detached house only needed 1 or 2 heat wells, but when larger real estates or district heating networks wanted to deploy this heating solution, they encountered that there was not enough space to drill as many wells as they needed. You had to drill deeper, but that wasn't the only challenge you had to solve. You also needed to design a new heat well design that enabled efficient energy production from a deeper well. These challenges were the ones QHeat decided to tackle when our journey started 5 years ago in 2018, as we decided to accelerate the climate goals of the built environment. QHeat geothermal wells, they are based on coaxial flow, which helps to keep the temperature difference between the cool and warm flow. This well design was innovated as the traditional shallow ground wells could not be scaled deeper because the heated liquid cools down in the well when it is transferred up, especially if the length is deep. Our heat well has a coaxial current and an insulated inner pipe. One well of the depth of 1,500 meters provide heating for up to 15,000 square meters of commercial real estates. And because the design is a closed loop system and doesn't need permeability of the rock, it doesn't even involve any seismic hazard, nor does it need any hot spots. So this is a globally scalable system. By reversing the current, as in the small picture on the right, we can get the same well to function as a heat storage and to extract cold from the ground to cooling. So now the bottom of the well is warmed up and it becomes a seasonal heat storage and a flexible component for the energy market. The heat well patent has been filed globally and consists of this heat well design and that has coaxial current that can be reversed. And our first heating centers provide energy and flexibility to different usages. Firstly, to district heating grids and to local low temperature heating networks, but also, as in our first pilot project, to a logistics center that has been heated up by this deep coaxial well since January 2020. So all of these projects would not have...
Sorry, I interrupt you there.
Oh.
I'm sorry, we have to go for Q&A.
Yes.
Maybe during the Q&A you can go deeper into some topic. So who here has questions for Erica?
I have a question, maybe. Yeah, you were talking about the pilot. That's one thing that I'm interested is in knowing what's the TRL of your technology, if you have any pilots besides the one that you were talking about, and so how mature is the technology that you have developed?
The technology is quite mature already because we have already 12 operational heat wells in Finland and 5 projects that we have delivered. So the TRL is somewhere maybe 8, 9, but it could be even a bit lower if we provide some digital tools to this system.
Okay, and so the way that your solution distinguished from the competition is the insulated piping. Is that the key difference?
And the reversed current in the well. These two
to work as a storage also.
Yes.
Okay. And what would a pilot with the EDP look like with you?
I wish that it would look like a local area, low temperature heating network that provides heating for several buildings in low temperature, where excess heat could be provided into the net and also stored in the heat wells.
Okay, and you are not bounded by any geography, or do you have any preference?
Rami,
we have started the process in these cold climates and cold crust here in Scandinavia, and that's like our home base. But it doesn't need to be just Scandinavian. Central Europe, for example, consumes even larger volumes of heat by area, and they are using gas mainly for the heating, so that we see the largest potential, for example, our system in Central Europe.
Okay, and so you do the drilling also, or just the installation of the pipes? The drilling also?
We needed to start by figuring out how to drill these deep wells, but that's not the way that we intend to scale up.
That's only in Finland, as we didn't have any drilling knowledge in Finland, but going international, we need local drilling partners.
Okay, thank you for your answers.
Okay, someone else?
Hello there. Thank you for your pitch. And so, after a pilot project, what would be an ideal business model with a company utility like EDP?
From our perspective, we see that the next step will be more of a technology sales and licensing that is based on the IPR that we have, the patents. But finally, there is a possibility to sell energy as a service, but that could also be the business model of our partner. So in the near future, we will be focusing on licensing business and technology sales.
Okay, thank you.
Okay, so we ran out of time. Thank you, Erica and Rami. Yeah, thank you. We'll let you know the results in the next few weeks. And
great.
Thank you. Have a great day.
Thank you very much. It was a pleasure, and I hope that we can continue to collaborate together.
Thank you.
Thank you. Thank you.
Okay. Okay, so now we're going to have a longer break. So let's be back in 18 minutes, okay? Not 20, 18. See you soon.
you a couple cuts later, now you're acting like a damn fool, like a damn fool. So ungrateful, I sit you at my table, now you're hogging all the damn food. It's so good, the blame is on you. There's no need to act like you still going to school and breaking all the rules. I'll take you back to class when I say you had your back in the beginning. Oh, that's right. Okay. But when did you get so good? I know that I need you now. The key that I won't forget, but you're lost in Paris. You're lost in Paris. Lost in Paris. I hope that you're warm and safe. The memory that I can't replace, but you're lost in Paris. You're lost in Paris. It was over in a day. All the things I used to say, you kept to say. All the places we would go, all the songs we got to know, you held it up. I know that I need you now. The key that I won't forget, but you're lost in Paris. You're lost in Paris. I hope that you're warm and safe. The memory that I can't replace, but you're lost in Paris. You're lost in Paris.
Hello.
Hello.
Okay, everyone is getting back. Okay. So the next startup is floating power plants, and Elena will be the one presenting. So João, you can let them in. Hello. Hi, Elena and Andre.
Hello.
Hi, welcome. Welcome to the Energy Starter. We are here with EDP and we're ready to hear your pitch. So go ahead, you can present your screen and you have 4 minutes to pitch. You have the timer there. Yeah, we can see it. I do not hear you, Elena. You're on mute.
Yeah, sorry, it will be under speaking. I don't know if.
Okay.
Yes.
Yeah, Anders is also muted. Let me see if. Exactly, yeah.
Okay.
We would like you to unmute.
Yeah, I was unmuted. So can you see my screen?
We can hear you now, but your screen was closed, Anders. So just try sharing it back up again.
So I have to share it again?
Yeah.
Let's see if that works. Good. So we can deploy offshore projects, but sharing a screen is hard. Can you see my screen now?
Yeah.
Yes.
Good. Then we'll try again. Good afternoon, everybody. So I'm Anders. I'm the CEO of Floating Power Plant. Floating Power Plant is a Danish company, and we are focused at delivering high-quality renewable power on demand. What that means is we are trying to decarbonize hard-to-abate areas. That is providing constant renewable power for off-grid applications, so large things offshore using a lot of power. It is providing renewable power on demand for regrid areas, that is remote islands or similar, and providing large-scale green hydrogen to be used in the shipping and aviation industry. Our technology is based on a floating wind concept, so it's a semi-submersible. You have seen those before. It is built out of panels, meaning it's cheap, modular, and is ideal for integration of other technologies. It carries megawatt wind turbines, it has a mooring system, and then to get the power away, you have an electrical dynamic cable or a hydrogen riser, depending on what you take off the platform. We always combine this with either batteries for short-term storage to spin up reserve capacity. We work with hydrogen offshore together with Technip FMC. So that is either to make hydrogen offshore and send it to land, or to keep the hydrogen on the platform and put it through a fuel cell to provide truly dispatchable power offshore. In some cases, we work with wave power, and here what we're trying to do is to get power when there is no wind, so a better power quality. It's the same concept, just in modules. We didn't start yesterday. We have proven our technology, including 4 offshore grid-connected tests with Ørsted, first floating wind, then wave, a significant amount of different basing testing, numerical models, and certification. The hydrogen system is right now being tested in Norway, so the offshore system is in its entirety. We do not develop alone. We develop to some very, very big partners, which is also our value chain. And for example, for the hydrogen, Technip FMC is our hydrogen integration partner. Most floating wind concepts are focused at providing foundations for large floating wind farms. We are not. Our combination of floating wind and hydrogen can provide renewable power on demand, which is ideal for off-grid markets, that is oil and gas, CCS, etc., or with-grid markets, remote islands, etc. These are markets that have a high energy price, and that means we don't need a subsidy to compete in these markets. Our scaling market is large-scale decentralized H2. So here we are talking significant space offshore, better wind, and an industrialized concept together with Technip FMC and a wind OEM will lead to competitive green H2. So FPP is in its essence a system integrator. We don't build anything. We do that with our partners. We deliver our technology as an EPCI or a lease. And our focus is on these markets where not LCOE is everything, but higher margin markets focused at power quality. Our next step is the first commercial demonstration project in Spain, in the Canary Islands. Here we will deploy a global flagship project, first proving floating wind and the full hydrogen system offshore. Then we will add wave power, and then we will have a 10-year R&D site to test new technologies such as control algorithms or electrolyzers, etc. This project has, over the last 4 months, received significant support, including 26 million euros from the Innovation Fund, 7.5 million from Arenas, significant R&D tax credit, and a technical EPCI investor have just confirmed a 10.5 million euro investment into this. The project, still under NDA, also is supported by a Tier 1 advisory board that will help us succeed in this market. We are owned by a strong investor circle. We have raised 25 million euros to date. That is governed by a working board. That means they help grow the company. Example, Carsten, the previous CFO of Maersk Oil and Gas and CEO of Total Italy. Hans, the previous sales director for both Siemens and Vestas, just to take a few. We have a strong team based in Denmark, UK, and Spain, and are growing the team as we speak. We do everything in collaboration, and the reason why we are here is that with the technical EPCI investor coming in, we are looking for other strategic partners and investors in our journey. And here we see EDP with your strategy and your innovation focus as quite ideal. So there is 3 things we would like to discuss on collaboration. One is a role in our demonstration project in Spain of floating wind and hydrogen, and then wave. FID next year, entering operation in Q1 27. We also want to discuss collaboration with EDP as a project development partner, especially on large-scale green H2 projects, as Portugal is very ideally placed for this, both with wind and its central position. And lastly, we are also closing a 20 million euro equity round in FPP. We already have over 10 million euros of that committed, but a smaller stake from EDP as a strategic investor, either in the parent or the company, we think is ideal for getting the right competences into scale. That is FPP.
Sorry to interrupt. We have to go for the Q&A.
Yeah, I'm done. So perfect.
Yeah. Okay, so who here has questions for Anders?
I can start. Hi, Anders and Elena. Thank you for your presentation. So this pilot that you are proposing, it will be in a single pilot to test the configuration of producing hydrogen offshore, mainly by wind energy resource, or also combined with a wave solution?
So the first part of the project is floating wind and hydrogen to prove that first, get that to TRL 7.8. Then you will integrate the wave power, prove that, and then you have 8 years after for testing new components, solid oxide, electrolyzers, new control algorithms. So we can test there before we put into commercial projects. So it's quite a strategic asset for us.
And so floating power plant is providing the floating structure. What about the equipments for this hydrogen production and then conversion?
So the hydrogen comes from Technip FMC. So they are the system integrator. So they will do the EPCI part. And they have not selected all the OEMs yet, but there is significant dialogue with different OEMs for the electrolyzer, fuel cell, and the storage system.
Okay.
The wind turbine will be a Siemens Gamesa turbine, to be clear.
At scale, right? For now, it's still at scale.
Yeah.
Okay. So Technip FMC would be the integrator one, right? The one that would take the license or the technology that you have been developing and build up the device.
Only the hydrogen part.
Okay. Okay. And the rest, you will be in charge of the manufacturing and assembly of the floating structure?
Yes, with support from Technip and a few of our other partners. But also where we see EDP can play a role, to be clear. You have a lot of experience with this.
Understood. Thank you.
Okay, Andres? Yeah.
Hi, hello, Anders. Thank you for your presentation. I wanted to ask you, where exactly in Spain are you planning to deploy the pilot, and what's the scale of the pilot that you are?
So it will be deployed in Gran Canaria, close to Las Palmas, in the Blocan test area, where we have a 10-year lease with that entity. It will be due to tip height restrictions, and there's a tip height restriction due to the airport, it will be a 4.3 megawatt wind turbine. It will be 1 megawatt of electrolyzers. It's about 2 tons of hydrogen storage, a 1 megawatt fuel cell, and it will have 0.8 megawatts of wave power in the second phase of the project.
Okay, thank you.
Felipe, go ahead.
Hi, Anders. Regarding the hybridization with the wave, can you elaborate a little bit more on what is the increase in CapEx and the corresponding increase in energy yields that you expect for it?
Yeah, sure. So to be clear, we don't have wave in all sites. We only integrate waves in strategic relevant sites such as West Coast Ireland, West Coast Portugal, and around US, where wind and wave are misaligned. So what we are chasing is the swell effect when there is no wind. So we would not do that in low wave resource areas. So the CapEx, what we are targeting is that it should have the same LCOE as the floating wind part itself. So the CapEx, so if you look from an LCOE perspective, the wave shall not add more cost of energy, but it should add increased power quality. Does that answer your question? We are at a pre-NDA stage before I start throwing euros per megawatt around, if that's okay.
Thank you.
Okay, last question from Lorenzo.
Hey, Anders. Thank you for your presentation. I'm Lorenzo from Ocean Winds. I'm curious on the floater design that you're using. You have your own specific floater that you're planning on testing and deploying, right? So, what's the plan on that? And also on in a second, different question is the hydrogen transmission that what is like you're producing it offshore? How are you transmitting it to shore? I know that you said that you're not, right? So perhaps converting.
Okay. Yeah. I will start reversely, if that's okay. So when we work with hydrogen offshore, there's 2 applications. One is we export it. So we export green hydrogen, so decentralized floating wind electrolyzer into a riser. Technip FMC is the larger producers of hydrogen risers in the world, and it goes to shore. So that's making large-scale green hydrogen offshore. And that is the scaling market. In the first applications, we will keep some of the hydrogen onshore. So you have a wind turbine that provides power to an oil and gas platform or a remote island. When there is then too much wind or there's curtailment, you take the excess power, turn that into hydrogen, you store it under power. When there's then too little wind or a need of power, then you put the hydrogen through a fuel cell and deliver it to the platform. So it's just a big battery. It's just talking significant more storage than with actual batteries.
And are you storing it in the floater?
Yes, storing it on the floater, yeah.
Okay.
And it's the same thing. It's what is being tested in Norway right now. You should go to Kongsberg. They are testing fuel cell storage and electrolyzer in an offshore setup, but onshore, making it ready for the offshore deployment. So all the technologies are at TRL 6, but right now it's scaling and integration time. Yeah.
Okay, thank you.
I'm really sorry. We have to go to
it's okay.
Q&A then. So Jose, I saw that you had a question. If any of you has extra questions, please write them here in the chat. Okay, we then later we're going to send it to Anders and Elena offline. Yeah, so thanks a lot for your presentation. We'll let you know the results in the next few weeks. Yeah,
Thank you. Thank you for inviting us. Bye.
Thank you very much.
Okay. The next startup is CalWave Power Technologies, and it will be Marcus presenting. So, João, you can let them in.
Yeah, hello.
Hello, Marcus. Welcome to the Energy Starter. So we are here with EDP, and feel free to share your screen, and you have 4 minutes to pitch. So go ahead.
Can you see my screen?
Yeah.
Perfect. Yeah. Hello, everyone. Mark Sleeman, co-founder, CEO of CalWave Power Technologies. Our vision is to unlock the power of the ocean. The main motivation is really that wave energy is the largest unused clean energy source and has great beneficial features, more consistent, predictable, and more energy dense. So a range of studies have found wind wave co-located can get to close to double the capacity factor, 90%, and the joint cost also go down respectively. Yeah, as of now, we're really lacking a dominant design in wave energy that is scalable like the modern wind turbine. Until now, we've developed and patented and proven the X-Wave architecture that mimics exactly the same features as the modern wind turbine. That is high performance, as well as the ability to shelter in storms, to fully shut down autonomously. So we've proven this technology now in a US record field pilot in San Diego, where we operated for 10 months continuously. You can see here the system floats on the surface for installation with a small boat. So we don't need as specialized and large vessels, let's say, as an offshore wind system. And then, yeah, it operates fully submerged. There's a marker warning buoy, Coast Guard compliant. But in general, being fully submerged has the benefits that, yeah, we can be much closer to an end user customer, causing no visual impact. And then at the same time, we put all the steel to work. So that's how we get really high performance by capturing all degrees of freedom. There are no moving parts outside. So all the power is generated inside by winches. And then, yeah, in storm conditions, we can shut it down effectively. And we're targeting these 3 entrance markets, microgrids, offshore assets, as well as then co-location with offshore wind. Now, for offshore wind, we're seeing really the first generation where wind itself is a newer industry and wave as well. So we can put them on the same export cable, but don't necessarily mix these farms from a certification and permitting perspective. So we're planning to offer 3 product lines, the X200, 800, and 1600, going to market from next year on. The technology originally comes out of UC Berkeley and the Lawrence Berkeley labs. And yeah, since then we've secured about 22 million in contracts with the US Department of Energy, as well as partnerships with National Grid and Baker Hughes. We're now the first company lined up in the US to deploy PipeIn. That's a 20 megawatt wave farm, specifically fully pre-permitted and cabled. And yeah, as I said, we're well underway in planning to deploy and operate them for 2 years next year with a PPA. So in general, we have a strong pipeline and growing with 25 active opportunities, about a 16 million in project pipeline. These projects will be demonstration projects. Until then, we can switch to our OEM business model where we want to provide the technology and services. So with EDP, we've identified 3 areas of opportunity: utility scale and wave farms comparable to offshore wind, Then yeah, utility scale in the US with Golden State Wind, that is the ocean winds lease area, as well as then island microgrids like the Azores. So yeah, in California, they just passed SB 605, which is a specific bill to look into wave energy, including wind wave co-location. Yeah, and how that could look in detail, we've picked that as an example project here for the Azores. We're proposing an 800 kilowatt microgrid. Yeah, we found a range of studies that yeah, baseload wave power really reduces the overall amount of storage needed for solar and storage microgrids. And yeah, adds that really reliable and baseload feature, as well as often islands yeah, don't have space and yeah, are very concerned about visual impact with tourism. So here an example timeline where we could start with a feasibility study this year and start front-end engineering, and then yeah, operate as early as 25, 26 once the X200 is fully qualified. Yeah, with that, happy to answer some questions.
Yeah, thank you. Right on time. Okay, so now let's go for the Q&A. Who has questions for Marcus?
Hi, Marcus. Thank you for your presentation. Sorry, Luis, you want to go? Okay, just a quick question. Thank you, Marcus. And as like you said, when it comes to wave energy, there is still a multitude of solutions to maximize the potential of it. So what would be the main features that you identify that are distinctive on your solution that you think are advantages compared to other solutions available?
Yeah, ultimately it comes down to dollar per kilowatt hour, so cost of energy delivered. We went through the US Wave Energy Prize. That was the first time in history of the industry where the Department of Energy benchmarked 92 different companies done under standardized testing conditions and then done by a third party. So the US Navy actually did a third party performance assessment, and yeah, we achieved the highest performing system. So that's where we really stand out in terms of performance. And then in terms of cost, yeah, most of the direct competitors have no means to shelter primary loads. That means they have to over-design their structure and their anchors. You know, floating wind, all their structures are passive. They're not designed to respond with waves. For wave energy system, we want to respond with waves, but then sometimes these very rare storms that don't really contribute to revenue, if you cannot turn off your system, yeah, then you're just over-designed. So the modern wind industry has achieved that with pitch and yaw control. And so, yeah, we've replicated exactly the same two features.
Understood. And for the pilot that you have proposed, how many devices would it be deployed for the one that you have just shown in the island of Azores? In this one, sorry.
Yeah, that would be 4 units of the X200 initially, and then we can upgrade it to the larger units as they come to market.
Okay, and the estimated in beginning of operational would be end of 25, right?
Correct, yep.
Yeah. Thank you.
I was just going to ask if you could tell us something about the principle of conversion. Maybe I didn't get it, but I understood very well how is the energy of waste transformed into power. What's the principle of conversion of your technology?
I see. It's a submerged pressure differential. So we, yeah, we're sitting underwater, capturing the pressure differential, and then inside there are winches that produce the power. So it's a tension system.
Okay, thank you.
Okay, someone else?
If anyone doesn't have a question, maybe I'll go, Margarida. Marcus, just a quick question, more curiosity. You were talking about that your equipment has the capability of shutting down when the weather is bad, when we have storms, and in the Atlantic, that is very normal. But how does the equipment does that? Is it via sensors? Do you use meteorological information? So how does the equipment recognizes that the weather is going to be very bad and shuts down?
Yeah, so actually we just see here in the video how we shut down. So we have 3 mechanisms. We go deeper because the wave energy density goes down exponential. So just going down a little bit deeper already brings down the forces. Then we can detune it, so we can take it out of resonance because the system is designed to swing with the waves. So if you over dampen it, that reduces. And then we also can release pressure through the center. That's a third. And these are all independent. In terms of controls, that's actually key of our IP is the trade secret we've developed about the controller. So this pilot, we operated 9 out of 10 months fully autonomous. And we have 2 layers of information that goes in. One is local weather data as well as global. So we can pull, we have a local weather buoy as well as just general weather data. But then even if we lose connection, so let's say the cable would fail, we are force controlled. So the wind turbine itself is speed controlled. If the turbine spins too fast, it would shut down. In our case, we measure the forces and the tension. If that gets too high, we gradually shelter. And because we can shelter with every resonation, essentially with every swing, we can shelter very quickly. That really worked very effectively. In San Diego, we experienced about 2 10-year storms because this was a scaled pilot. So in a full-scale environment, this would have been 2 10-year storms we survived.
Perfect, thank you.
Okay, that's it. Thank you, Marcus. Thank you for your presentation, and we'll let you know the results in the next few weeks.
Great, thank you, everyone.
Thank you.
Thank you.
Okay, so next we have CalWave Power Technology. BeeX Autonomous Systems, and it's going to be Grace presenting. So, João, you can let Grace in. Hi, Grace.
Hi.
Hi, welcome. So we are here. Welcome to the Energy Starter. We are here with EDP, and you have 4 minutes to pitch. So feel free to share your screen and start.
One second, Margarita. I think she came back to the main room by accident. Yeah, sorry about that. I have sent her the request to return back here. I am not sure if she disconnected or if she just misclicked. Let's see.
We have Grace again. Hey, Grace, can you hear me?
Okay, I think it should be fine now, Grace. Yeah. Just try to share your screen. You're in the correct room now.
Okay.
Okay.
Yeah.
Here we go. Yeah, it's sharing.
Okay, great. Grace, we are here with EDP, so you can start your presentation. You have 4 minutes to pitch, okay?
Okay, great. Good afternoon, everybody. It's like evening at my time, but my name is Grace. I'm the co-founder and CEO of BeeX. BeeX design, build and operate autonomous underwater vehicles to transform how underwater capabilities at scale can be completely changed. The problem that we are trying to solve in the market today is that we see an exploding need for underwater data. And this problem gets bigger and bigger when the scale of infrastructure increases. As of today, we have solutions for nearshore infrastructure, and we also have super expensive solutions for offshore infrastructure. But we see a bigger and bigger need for good data in the field of renewables, nearshore infrastructure, and defense use cases. When you have many of the same objects, it's no longer viable to use large ships and large amount of resources to carry out the inspection. BeeX uses intelligent autonomous vehicles that are completely independent of operator control to help asset owners achieve 20 to 50% cost savings when carrying out O&M works throughout the lifetime of the asset. This is mainly achieved without requiring support from large ships to be mobilized to carry out the jobs. This also helps to achieve at least 50% reduction in operational risk by reducing the number of personnel required on site. By removing the vessel for support, we are also significantly reducing the CO2 footprint of the inspection jobs. BeeX is acquiring this track record through 12 years of data that we have collected of underwater infrastructure to help our vehicles intelligently navigate when carrying out these autonomous inspections. To build such vehicles, we have iterated over 25 cycles to achieve the optimized hardware and software configurations for carrying out such inspections. Today, we have 5 vehicles operating across 3 continents. Our HQ is in Singapore, and actually we have worked with a subsidiary of EDP here in Singapore. We were awarded a 4-year continuous O&M inspection contract to carry out inspections on their floating solar farms. And one of the reasons why we decided to participate in this challenge is to look at how this technology can be scaled to other large-scale infrastructure owned by EDP. We work for offshore wind farm operators, oil and gas service providers, and also the government sector in reducing their cost and risk. How we do this is a fully integrated end-to-end approach. First, the vehicles that we design and operate are already pre-calibrated before going on field. This allows for fast mobilization. Using the fully integrated software platform that we have, we are also able to carry out real-time measurements when doing these inspections due to the unparalleled computing capabilities that we have on board the system. So instead of sending data back onshore, we actually process the data in real time on the vehicles. And all this information is then reported on a cloud-based reporting portal, where we also have AI classification software to help asset owners understand what is changing to their infrastructure over time. This technology was demonstrated on an offshore wind farm 2 years ago on North Sea 1, owned by Northland Power in Germany, and then replicated on Deutsche Bucht last year, and also on HKZ offshore wind farm owned by Vattenfall. What we validated was that our vehicle, although way smaller, only requires a fraction of the resources required to carry out the inspection, yet we are able to match the productivity of these large systems. We are also able to carry out inspections of floating infrastructure, and asset owners can carry out real-time measurements of their infrastructure. Today, we have 2 vehicles. This Ikambilis, which is a more compact system, is the one that we have deployed. For operations that require more manipulation capabilities, such as spot cleaning, we are deploying the largest system that will be sent over to UK in Q2 this year, and we hope to validate it on other large-scale infrastructure with EDPR. We hope to work closely with asset owners to help them reduce their cost of underwater inspections. Thank you.
Thank you, guys. So who here has questions?
Yes, I have a question for Grace. Grace, what was harder for you to develop? The almost real-time transfer or onboarding 7 sensors? in the device?
Yeah. So the biggest challenge is to help the brain become intelligent. So we need to deal with all the edge cases that the vehicle might experience in different wind farms. And that means that we need to leverage on the years of data that we have collected across different types of environmental conditions. Having the hardware was a part of the puzzle because previously, before I started BeeX, I actually sold ROVs and like rented all these sensors as my previous job. What I realized was that the traditional ROVs today are not suitable to be autonomous. So it's like the revolution between electric cars and petrol cars. The whole entire hardware, almost 70%, doesn't support autonomous operations. So we had to build up a new hardware platform to achieve that autonomous capabilities.
Okay, thank you.
George, go ahead.
Yes. Good afternoon. It's Margarita, it's me or the other George? I didn't put my hand up, but I can do a question.
It was you, yeah, you were
Okay.
before it.
Hi,
Yes.
Grace. Thank you for your presentation. So your solution, what kind of inspections does it perform nowadays? Visual inspections only? Are there any other inspections that you foresee and that you are willing to integrate on the future?
So we have done all the way up to non-destructive testing as well. The only type of operation that we think cannot be handled by our vehicles today is repair. So if you require like some sort of like cutting and intervention, we don't think that that's suitable to be done by autonomous vehicles yet.
Understood. So your solution is autonomous. So I see that it has a tether that is attached to the boat.
Okay. In this case, the tether is optional. So
Okay.
in this case, the operator actually wanted real-time feedback. That's why the tether is there. So our tether is not for power. The tether is only to allow the on-site. In this particular instance, we were deploying the vehicle with marine biologists that wanted to see the data as we were collecting it.
Okay. Otherwise, it would have to be downloaded from the vehicle once it is retrieved from the sea.
That's correct. Today, we through our acoustic modem, we can send snapshot pictures. So you will get like one frame every 15 to 20 seconds picture, but you don't get a live stream.
Understood. And how is it traveling? Is it remotely operated or it is fully autonomous in terms of the path that it can take?
It's fully autonomous. So we have validated this on a 6-meter diameter monopile. We never saw that monopile before, but based on the data that we have collected earlier in other locations, the vehicle was able to recognize the cable protection system, the anodes, and carry out the inspection without active human control.
Understood. And what are the maximum depth that it can go and the transit, I mean, distance range that it can go without getting lost, let's say?
Yeah, so today we do we typically get the crew transfer vessel to bring us to the turbine, and then we operate within the boundaries of the turbine. So usually around 100 to 300 meters away from the turbine with the current small vehicle that we have. The larger system will allow us to transit from turbine to turbine. So looking at 3 to 4 monopiles in a single dive. Our operating depth is 300 meters. But so far, I think the challenge that the asset owners want us to overcome is the current fighting capabilities as we transit from turbine to turbine.
And what is the autonomy of the battery of the device?
Currently, the small vehicle, we have 1 kilowatt hour, allowing us to work for about 2 to 3 hours. The larger one is 10 kilowatt hours, so that can last for 24 hours.
Thank you very much.
Thank you.
Okay. Thank you, Grace. We don't have more time for questions, so thank you for the presentation, and we'll let you know the results in the next few weeks.
Yeah, thank you. Take care. Bye-bye.
Thank you. Okay, so next we have INALIA, and we have Alex and Hainoa presenting. So you can let them in. Hello.
Hello.
Hi. Okay, you're both here. Okay. Hi, Alex and Ainoa. We're here with ADP. Welcome. They're ready to hear your pitch. So yeah, go ahead and share. Yeah, we can see your screen. Yeah, you have 4 minutes to pitch, and then we'll go for Q&A. Okay? So go ahead.
Okay. Okay. Oh, sorry. I don't know what is happening. Okay. So first of all, thank you for giving us the opportunity to present our proposal for this CDP's challenge. Risk and cost in floating wind power are too high, but they can be reduced through structural health monitoring systems. But all existing structural monitoring systems designed for demonstrative units are not scalable to commercial parks because they are based on intensive monitoring, so they are expensive. They have many sensors that have some durability issues in offshore environment, and the amount of data per wind turbine is too high. CimeWind, our solution is CimeWind, and overcomes these limitations, making it a scalable structural health monitoring tool for commercial parks. And it predicts from minimum sensors the rest of structural key parameters that are needed to analyze the structural health of all subsystems. And which is the technology behind CimeWind? The technology is a minimum sensor data from inertial measurement unit, EMU, and GPS, straight measurements on sensors on tower base, as well as external conditions data. All these data are used to get position, dynamics, and total loads on floater. This makes CimeWind a cost-effective solution with no durability issues and independent of the SCADA. All this data, combined with a simplified real-time hydrodynamic models and artificial intelligence tools, are used to predict total loads on moorings, tower interface, and floater. These loads are key structural information for further structural health analysis. CimeWind combines load information, structural models, learning anomaly databases, and trained artificial neural networks to analyze the structural conditions of moorings, floaters, dynamic cables, and detect working anomalies, prevent risk situation, and do predictive maintenance. So CimeWind structural health monitoring means more availability through early detection of working anomalies, for example, detecting problems with the mooring line, less maintenance costs by providing useful predictive information like accumulated structural damage on welds, bolted joints, or the remaining fatigue life in critical interfaces. It also mitigates risk, continuously analyzing the remaining useful life of the asset and reducing in-person inspections. For the pilot program, our main goals are to adapt and validate CimeWind's structural health monitoring to the floating technologies of EDP Ocean Wind Float project, and to provide EDP with a floating offshore wind turbine structural health monitoring tool that is scalable to other commercial parks. And the pilot program schedule would be as follows. This EDP challenges the starting point to have access to the real data collected by the monitoring system of the prototypes installed in Viana do Castelo or similar ones. In about 4 months approximately, we will use the real data to adapt CimeWind to the characteristics of the platform by feeding already trained machine learning algorithms and CimeWind databases and correlated digital twin. In about 12 months, we'll be in position to analyze a CimeWind prediction accuracy of total loads. And in about 14 months, we could provide with structural health information. Which type of information? our idea is to provide with a scalable structural health monitoring tool for commercial offshore wind parks that is cost-effective, accurate, and available through the asset's life cycle. And this includes information about the mooring loads prediction with simplified real-time hydrodynamic models and artificial intelligence, algorithms for detecting anomalies in moorings based on platform dynamics, knowledge about the relationships between external conditions and floating offshore wind turbine dynamics, critical interface structural fatigue analysis, histograms, and so on. And
I'm sorry, I have to interrupt you there. We ran out of time. So we're going to go for the
I have
next
already finished.
Yeah,
Yes.
great. Okay, right on time. So who here has questions?
Hi, Ainhoa. Thank you for your presentation. What is the track record of this solution of yours? Has it already been used in some kind of analysis of an existing assets?
As we are different modules for Tsubame, one module is the mooring lines, another module is the dynamic cable, the floating structure. We are using some of the modules in different type of projects. For example, with the mooring lines, we are involved in a project of a wave converter asset. So we are applying this knowledge on this type of project. But until now, we haven't developed a complete integral monitoring, structural health monitoring system for a floating wind turbine.
Okay. And you don't sell any kind of devices of sensors, you just receive or use the data that is provided by this kind of equipment to work on it.
Yeah, we do the engineering to define where to install the sensors, but the sensors mainly are commercial ones, although we have our in-house sensors for the monitoring of the voltage joints, but mainly they are commercial ones, and we provide with the best option according to the project. And our value is to get information from the sensors and to provide with the structural health information. We don't sell sensor, but we install the sensor, we define where to place and where to install and how to install and do all the installations.
Okay, understood. Thank you.
Hi, hello. Dio Kurder from EDP Produção. I have a doubt regarding your model. Your model is designed for offshore, but could be adapted for a floating PV on a dam, just to simulate the mooring forces and to detect some anomalies in the structure of the pontoons.
Yes, in fact, it's one of the products we are developing more or less in parallel, because there are some topics that are common needs in PV floating. So, and one of the modules, like moorings, is one of the modules that we are sharing technology and know-how and experience with Tsubame for the solar floating. Yes.
Okay, thank you.
Jorge, go ahead. You're in mute.
I cannot listen.
Yeah.
Sorry, I was muted. Hello, Ainhoa. One question regarding your algorithm. In order to train your algorithm for extracting conclusions, how long does it take learning phase, and where do you take the data from? Only real data from experience from the sensors, or any other sources?
Up to now, we have already trained algorithms, and we have trained all the algorithms with more than 8,000 hours of synthetic data extracted from OrcaFlex hydrodynamic virtual models. So our algorithms are already trained with synthetic data, and the next step is to get real data to improve the algorithms and to improve the accuracy of load prediction of them.
How long does it take? the process of acquisition of real data?
I don't know if many of the assets are already getting data, so we need data from a representative campaign. I mean, we need data from let's say 6 months, more than 6 months, up to 1 year. I don't know. It depends on the of the place. We need that data to be representative of all conditions, working conditions of the wind turbine.
Thank you.
Okay, thank you. We ran out of time, so thank you for your presentation, and we'll let you know the result in the next few weeks.
Okay, thanks to you.
Thank you.
Bye.
Bye. Okay, so now we're gonna have first Airborne, and it's gonna be Boaz presenting. Sure. Hi.
Hello.
Hello, welcome. We are here with EDP. Yeah, I don't know who's gonna present.
I will. That's okay. Yeah.
Okay, so go ahead. Feel free to share your screen, and you have 4 minutes to pitch. Okay, and then we are gonna go for good.
But only when I start sharing my screen.
Sure.
Okay.
From now. Yeah.
Great. Hang on. Is this showing?
Yeah, perfect.
I was told to put this on full, so good. Okay. So my name is Boaz Peled. I'm founder and CEO of First Airborne. I saw the guidelines, so I'll try to get right through them. Brief introduction to, I've been in wind power for a long time in operations, development, and we set up this company to really deal with a lot of the scaling issues and performance issues in wind turbines. Essentially what First Airborne does is performance testing. So we consider performance testing, answering the question, is a turbine performing or generating correctly versus the wind condition that it's, the wind resource that it's harvesting. Briefly about the company, we are now commercially operational throughout Europe and the United States. We've been operations commercial for a little bit less than 24 months since our technology has been, let's call it, come to the place of maturity and validated and certified. And we have, this is actually not entirely updated, we have now tested beyond 800 megawatt in wind power. Large farms, small farms, I'll share more details on that in a minute. The problem we're trying to help solve, I don't think we'll solve it all by ourselves, yeah, is a question of underperformance in wind turbines. We think this is worth something in the range of currently $3 billion a year. Turbines performing below where they should be performing. And that's obviously growing with the industry and growing with the sizes of turbines. So the problem is already quite large and becoming larger, both on and offshore. Why is this happening to a large extent? Because wind turbines are very difficult to be tested. Okay, so if we look at the current ways in remote sensing, which what we call direct measurement, so we're looking at the wind. What is actually the wind that's being harvested? The ways to do it today are usually through LiDAR or wind mast. They can do 5 or 6 turbines a year, heavy logistics, craning, very limited because of their stationary nature, which is why First Airborne has developed this guy over here, which you can see here in my hand right here, okay, which is a especially smart device. And the best way to think about Windborne, which is a global patent now, is a flying wind mast. That's the best way to think about it. So we can position a very accurate measurement device anywhere within a wind farm, which is creating huge benefits in terms of the amount of valid data which is becoming available, and therefore the amount of turbines that can be tested and megawatt hour that can be recovered. If we look at this is an excellent example. So when the wind direction changes, what actually happens is that we're able to reposition the flying wind mast and collect additional valid data. You can see an example in this wind farm where the wind is coming from 2 different directions, different positioning, is creating different turbines for testing. And that's creating a huge amount of valid data for a lot of machines. Example, we've just finished 70 turbines, of testing 70 turbines in Texas a few weeks ago. It took us 3 months. LiDAR can do 2 machines. At the time that we took it, it took us 70. Why? Because we can move. A few more examples. We're very light on the go. Within 1 hour, we can start measuring, no building permit, no cranes, nothing of the sort. Important, technology is entirely validated after significant validation and certification campaigns in Germany. You can see here the results, both perfect on wind speed and wind direction. This is the first class wind measurement instrument in every respect. A little bit about where we operate. So these are different sites, different case studies. Interesting. I'm not going to go through the results on each one. There's the question of yaw misalignment. You can see here. There's questions. This is an example. This is how the customer would receive the data. 70 turbines. This is the very same wind farm. 4 in disastrous mode, entirely swaying from the wind. Reduced power curves. A few in yellow. Most of them are obviously okay. So we're looking at 15–20% of wind farms generally underperforming. That's our experience. Same thing with power curves. To generate a power curve in a wind turbine today will take you 3 months. We can do dozens within a month. Okay, simply because we can move and we create a lot of high resolution data. This is my last slide, because what this actually means is that if we're looking at our current competition, it costs them to recover a megawatt hour due to corrections in the turbines over 200 euro. Now, you guys are producing wind energy at average between America and Europe, somewhere around 60 euro per megawatt hour, let's just say, depends on your PPA, 50, 60, let's just say. You will not pay 200 to get that extra recoverable megawatt hour. We are currently below 11 euro per megawatt hour for recoverable megawatt hour through performance testing. I know I took up a little bit more than 4 minutes. I hope you're not too angry. There you go. I tried.
I waited for the, for the right. Okay, so now I'm sure you have lots of questions. So go ahead. Who's first?
Maybe I can jump in. So hi, boss. My name is Mafalda and I work at EDP Innovation. So my question is more related with the pilot that you are proposing to EDP. Can you please elaborate a bit more on that?
Sure. So look, our significant interest is that for EDP to test or to experience. I think that's the best way to experience what Windborne can do. How quickly we go and give a very accurate data, which is almost impossible. Let's say impossible with software tools and very expensive with non-software tools. And we would like to set up preferably in Europe, because it's just easier for us. We have a European team. We also have a small American team. We generally advise that, we can do many turbines in a short time. Doesn't make sense to bring us for 1 turbine. So we would like to do wind farms of 30, 40, 50, 60, 150, doesn't matter. That's really up to you. Machines. And then you can actually see very nicely the amount of recoverable megawatt hour through adjustments simply because of the data. So what we actually want to do is deploy, decide together what is the success criteria, which turbines need to be tested, how data flows from us to you. This is generally 1 to 2 day planning, total of 1 to 2 day planning, sometimes less, and then deployment for as long as it depends on the amount of turbines.
Okay, thank you.
Okay, next.
Maybe I can make another question. Is there any limitation regarding offshore environment?
So we have our first offshore project this year in Norway. So the limitation in airborne systems is really eventually boils down to battery. So if you look at how we operate like on daily. So we have a team that is supervising. Everything is robotic and automated, but we have a supervisory team on the ground. In this case, they will have to be in a boat or on the substation. We will have to plan it differently. But in terms of the actual operation offshore in the sea or not, no, the system is prepared to perform offshore.
Okay, thank you.
Thank you. Jorge, go ahead.
Yeah, just one question on the technology. When measuring the wind resource, typically we use static sensors, but you're proposing a dynamic one. So what are the difference and the corrections that you need to make in order to make sure that you are not interfering with the measurement?
Okay. That's a brilliant question, but it really entirely goes to the technology. Okay, so the answer is we are non-stationary. That's absolutely correct. Yeah, we are non-stationary. However, the measurement is stationary from a measurement point of view. When this guy, and you can see it on our website, you can see you know, the actual videos of how this goes. The aerodynamics of this sensor actually beyond wind speeds of 4.5 meters per second, turn it into an entirely static, from a vertical point of view, an entirely static sensor. The drone, you are right, is hovering significantly, but it has zero impact on the sensor itself. So effectively, the way to think about it is a sensor that's stuck in the air. And you could actually see this both in video and in data. But you asked about corrections, which is an interesting topic, because we you know, when you develop such a technology, you're never sure how good will it be. Of course, we've tested it against first-class wind masts, and we are. I've only seen one LiDAR, which has had such results, such as ours, relative to the wind mast. But what we do have the possibility to correct data in terms of we measure acceleration, we measure tilt, we measure vectors, we measure 360s, we measure obviously pressure and temperature, etc. Everything is packed into this little guy over here. But what we've realized, very interestingly, is that the windborne sensor reflects the wind, I would say virtually 1-for-1, because of very low inertia, and we have not actually needed to input corrections based on the movement of the sensor in order to come up with the results. So it was prepared for that, but we only do it for filtering of very extreme situations, such as a very strong unexpected gust, as an example. Yeah. But then we have that filtering capability, and we very, very rarely use it, which is a very interesting thing. We weren't sure we would be in this situation.
Thank you. I'm sorry, I know there's more questions. Luis, you can write the question in the site,
yes.
And then we'll forward it, okay, to them. So thanks a lot for your presentation. We ran out of time, so that's it. And yeah, we'll let you know the results in the next few weeks, okay? Thank you.
Thank you. Take care, guys.
Thank you.
Ciao.
Thank you. Okay. Okay, so now let's go for a quick break, a 5-minute break, okay? And we'll be back in 5 minutes. Yeah.
Young, all in love in a lost place. Goddamn, got me running around in a race race. Say grace, Lord, I fell in love with a small waist. Let me start, yeah, right, yeah, bang, shot me in my heart and it hurt case. She's so fly like a dove, that's a dove face. Don't know where she at now, but it's in her birthplace. Tom, don't tell her, but it's first for
I know
birthday.
that I need you now. The key that I won't forget, but you're lost in Paris. I hope that you're warm and safe. That I can't replace, but you're lost in Paris. I know that I need you now. The key that I won't forget, but you're lost in Paris. I hope that you're warm and safe. The memory that I can't replace, but you're lost in Paris. I need you now. The key that I won't forget, but you're lost in Paris. I hope that you're warm and safe. The memory that I can't replace, but you're lost in Paris. Just hold me. I'm a lonely heart. You've been miles away. Held up at the border. Just hold me. I will never get hurt. You've been miles away. Heavy California. Under levy California. They say heaven waiting for you. So I'm headed for California. Oh Lord, California. Oh Lord.
Hello. Is everyone there? Okay. Okay. So let's go to the next startup, which is Windscape AI, and it's going to be Eric joining us. João, you can let Eric in. Hi. Oh, good.
Hello.
Hi, Eric. Welcome.
Oh, thank you.
Welcome. We are here with EDP and we are ready to hear your pitch. So go ahead and share your screen and you have 4 minutes to pitch.
Thank you. While I click some buttons, thank you everybody for being here. And let's see, it seems to have changed a little bit. Do you see a presentation?
Yes, I can.
Okay. Thank you everybody for being here. Just one logistical question. I see a countdown timer, but it's not counting down. Should I keep my own timer?
Yeah, go ahead. It will start counting as you start to speak.
All right. Well, I'll then start to speak. Thank you, everybody. So this is Windscape AI, and our reason for being, mission in life, is to apply the latest AI techniques, some of which that we have developed internally, proprietarily, to wind energy problems. And we also are leveraging a great deal of internal wind energy expertise and also AI expertise. Our team is small but growing. I am the Chief Commercial Officer and have a deep background in the wind industry, mechanical engineering, and then business development, including being co-founder in wind energy startups. Jason is the lead on the machine learning. He has a PhD from Cornell and a fair amount of prestige in the machine learning world, including helping to stand up Uber's AI labs. And we have an excellent machine learning scientist working with him named Sam. So the problem we are addressing is that wind turbines are chronically off yaw. And that's been shown in many studies, and losing literally billions of dollars a year in energy. And it's chronically difficult to diagnose and fix that because of the many sensors, the many systems that are out there. And we approach this with AI using just the SCADA data. So no additional sensors, no additional equipment in the field, no interference with operations of the wind turbines. And we have been showing through our studies and in the 3 pilots that we're conducting that we can detect these yaw errors and transmit that to the customer. And the basic model is this low-cost, small set of data from SCADA, our AI techniques, and then transmitting this through a SaaS interface to the customers. We are also beginning to add additional products to this. So moving on from AI to yaw to pitch errors, and potentially ice and wake steering. We have 3 pilots up and running, and we're just next week going to install another pilot in Europe. What we want from these pilots are expertise from our partners to help us detect, demonstrate, and troubleshoot the yaw and other detection. With a minute to go, I will showcase a version of the results. The short version of this is there's a lot of data at the bottom that goes in, and we're able to show the customer, in this case, you're off by 7 degrees for this particular turbine. And we can do this very quickly for a large set of turbines and across multiple wind farms. You guys are familiar with this industry, but it's a very large value proposition that we address. And our approach is not just to do the analysis, but we also understand that the commercial engagement is very important. And based on my experience, marketing and developing products in the AI wind space, we're going to approach this with a very user-friendly, customer-friendly engagement process. Our objective is to finish our raise right now and engage in as many pilots as we can to perfect this.
Thanks a lot. Right on time, Eric. Okay, so now let's go for the Q&A. Who here has questions for Eric?
Maybe I can jump in again. So, hi, Eric. Thank you for your presentation. What type of data do you need from our side, or what type of parameters and signals do you analyze with your AI models?
Thank you for going back to screens that I needed to skip over. But the basic data that we're looking for is the wind speed, the wind direction, the relative wind direction, and generator output. Ideally in 1 Hertz mode. We find that this is a small set of data to request from the SCADA. Sometimes wind farms are not accustomed to doing that at 1 Hertz. They're more used to the 10-minute data. But we have found that through PiSync and other sources, we can get that data with relatively little headache on the side of the customer.
Okay, thank you. And I saw in your slide that you are trying to achieve 1% of AEP increase, right?
Minimum, yeah.
The minimum. And what's the maximum expected?
From the studies, both academic and industry studies, 3% might be the maximum, and that would be across the wind farm. Individual turbines could get up to 6% improvement in AEP because individual turbines can be chronically way off yaw.
Thank you.
Any other question, Mafalda?
Maybe I can do another one regarding your pilot, the proposal for the pilot with EDP. Can you elaborate more on that?
Sure. The usual course of a pilot is identifying a wind farm or 2, ideally, and engage, setting up whatever paperwork contracts with a large organization like EDP is necessary, and then talking with the asset managers about mostly this data set, downloading that data set to us, doing an offline analysis, which might take a couple of weeks once we ensure the correct formats and so on, returning results that demonstrate the yaw correction opportunities, and then working with the asset managers to do probably some A/B tests, making yaw corrections through the SCADA as opposed to needing to do anything in the actual turbine operating system, making yaw corrections to the SCADA, and doing some measurement of EEP improvements. And all this could be a few months time frame, and it could be all remote as well.
So is there not a preferenced geography for the pilot, right?
True, except that 2 of our pilots are in very flat, even terrain. So it would be interesting to do a next pilot in, say, rolling hills or offshore.
Okay, thank you.
Okay, I think we're running out of time. So if anyone else has questions, you can write here in the chat and we'll forward them to Eric offline, okay? Okay, so Eric, thank you. Thanks a lot for your presentation, and we'll let you know the results in the next few weeks.
Very much appreciate it. Nice to meet you all.
Thank you.
Bye-bye.
Okay, so next we have Werover. We have Furkan. João, you can let him in.
Hello, everyone.
Hi, Furkan. Welcome. We are here with DDP and we are ready to hear your pitch. So go ahead, you can share your screen and start anytime.
Okay, guys, I'm sharing my screen. If you can see clearly, please inform me.
Yeah, we can.
As a Werover, we have founded in 2018, and we started our journey in renewable energy sector in hydropower centrals. Then we decided to move forward in the wind process. And guys, when we show the case in the wind energy market, this is the biggest market of the world, and they're growing like insanely, 900% in the last year they have grown. And we have noticed in this sector, there is a one big main problem. It's the blade maintenance costs are unpredictable. And when we check that, it's like annual operational maintenance cost is $21 billion for whole company and all around the world, and $5 billion year for yearly blade maintenance is taking their share. And if you lose your blade, it could cost more than $1 million. And we decided to create a product, and you can see while in this video how we are working. Werover. We aim to help the risk and the cost of the blade losses. And what we are doing the real-time health monitoring, and we are analyzing the blade sound. And when there is a damage when we find any damage with our AI and machine learning system, we are doing the early damage detection. With that way, we are reducing the downtime cost, optimize the service life, and also minimize the unplanned downtimes too. And as you see, our products also app and very easy to use too. How it works part, we had a simple hardware in these slides. It's not that big at all. And we are listening the blade, wind turbine blades, and we are putting that data on our clouds, and then our machine learning the healthy blade sounds. Then when they detect any damage could happen, our AI system saying, whoa, stop. There is a damage in here, and this is the size, this is the cost. You need to take an action, and blah blah blah. This process notifications going to wind turbine technician, and they're taking action or not, depend on them. And here you can see the healthy blades data and damaged blades data. This is the difference actually, two of them. And then when we detected the damage, we are sending this kind of information notification to our app. In competitor part, we have competitor in all around the world, but not directly competitor at all. But in our case, our competitors are mostly not doing the damage categorization, and their AI side is not that strong as our product. As we experience from our customers and the pilot customers, our AI system can detect the our machine learning system can learn the health blades data in just 2 weeks, but most of the company is doing that like 4, 5, 6 weeks or around that. And our plug and play installation without any cable is also giving a chance to expand sending our product in the whole around the world without any team. We have 10 customer right now in 4 countries, and this is our prices for onshore and offshore turbines. Also, we had a partnership with insurance firm, and also we have first paying customers. I don't know, like we didn't have change this slide. Sorry about that. And our pilot customers, MBV, Envision, and European Energy, some kind of big company like this. And also our 5-year goal, selling our around 27,000 products to turbines and earning $100 million. And our key milestone is right now we just expanded the UK, and right now we started the selling process, and then we would like to grow in offshore sector especially. This is my lovely CEO and lovely CTO, and we have a close partnership with Alchemist Accelerator, Climate Finance Accelerator, and the Bremen University and Gruen Offshore Tech site. And we have successfully done of their programs, and we have achieved so many points in there. And here, this is all about us. Thank you so much.
Okay, sorry, I was going to interrupt you. Okay, thanks for the presentation. So now let's go for the Q&A.
Yes. Should I stop the sharing screen, guys?
Maybe you can keep it a bit longer, because if there's some information you want to show.
Yeah.
Okay, so who here has questions?
I can jump in. So hi, Furkan, thank you for your presentation. So how many sensors do you need to put on the wind turbine to make to detect efficiently the blade damage?
One.
Just one?
Just one.
Okay. And you install it on the tower, right?
Yes, on the tower.
Okay. And what type of damages are you able to detect? You mentioned the damage due to lightning strikes.
Lighting, abrasions, icing. Right now, we are getting stronger in icing process because we are working with the Scandinavian part, and also icing problem is a big problem in Turkey too. Yeah, right now we are improving our icing sides. We have done with abrasion and lighting sides.
Okay, thank you.
Who's next?
Hi, Furkan. Could you go back to the business model? So you mentioned 3,000 per sort of an onshore.
Yeah.
So you only work with subscription model, right?
Yeah.
Do you have installation
annual
fees?
subscription fee we are gathering. We are not getting asking money for sensors.
Okay. But do you have a installation fees, or are there any other fees besides
This is the
ones?
point. Yeah, this is all annual subscription fee. Just you need to pay the fee, nothing else.
Perfect. And regarding the pilot, could you detail a bit more how could you demonstrate this in one of our wind farms?
Sorry.
What would be a normal pilot with a utility company for you guys?
Yeah, actually, our normal pilot process, we get to know you, and we are signing NDAs. Then we are signing a pilot agreement document. Then we are you are selecting the wind turbines, wind farms that you would like to put our product, and we are just sending in a packet. Then you are opening the box, and you are putting the sensor on the tower. We have powerful magnets, and you are just putting on the tower and click the button, and it will start to work. And it's working with some solar energy, so you don't need to think about the energy too. It will work until forever. Actually, until 3 year, 5 year.
Okay, so there's no maintenance required or calibration or anything.
No,
The
nothing.
device.
Yeah, nothing.
Thank you.
You're welcome.
Hi, Furkan. I have a quick question. How do we ensure the communication between your devices and your cloud? Especially taking into account that sometimes these assets are in remote locations.
We are using for that what was the name of it? We have started working with the mobile phone companies in the beginning. Then we find out to gathering information with new software system is way more easier. And right now we are working on it, and we are improving on it. We are using it in our pilot session. So in this process, we are sending our box to you, and when you start it, our boxes, our software system, finding the most available mobile system, and connect with that mobile system and gather data like that. So we don't need any extra agreement with mobile cell phone companies or anyone's on this process right now, and not anymore.
Okay, thank you.
You're welcome.
Okay, that's it. Thanks a lot, Furkan, for your presentation, and we'll let you know the results in the next few weeks. Okay.
Thank you so much, guys. Bye.
Thank you. Bye. Okay, the next startup is Tarucca. We're gonna have Hans and Hernani. João, you can let them in. Hi, Hans. Okay, I cannot hear you, Hans. I think you're on mute. Um,
Now you should be able to hear me.
yeah, exactly.
Yeah,
Hi, welcome.
I was automatically muted, so okay.
Yeah, sorry. So we are here with EDP, and we're ready to hear your pitch. So go ahead. You have 4 minutes.
Okay. Thank you for the attention. How do we keep the wind-float Atlantic turbines and the other EDP wind farms supplying green energy in the decades to come, when there will not be enough engineers to inspect those blades of all those 10,000 wind turbines at sea, and the large blades would start failing more and more without predictive maintenance? Together we can. Bigger blades require a solution that provides the data and the signals to enable predictive maintenance. At Tarucca, the future we imagine a world where the blades tell you what their structural health and condition is, and when they need further inspection and maintenance, without requiring wind turbine stoppage, reducing the need for dangerous human intervention and ecological disturbances, enabling optimized electricity production, costs, and blade lifespan planning for a more circular and sustainable world. The current visual blade inspection methods, they're not supporting efficient predictive maintenance practices. And with drones, you cannot look to the damage that is, say, not visible on the outside. Our solution is a remote rotor blade condition monitoring system with simple optical sensors that can be easily retrofitted, AI algorithms to detect the shifts in vibration patterns, because that's what we measure with accelerometers, giving strong indicators for the condition and the structural health of the blades. With our system, based on the discussions that we had with asset owners, there is a very positive business case for wind park owners and operators because of performance gains, maintenance savings, and lifespan extension. Our solution beats alternatives because it's more durable and reliable than others. It's real damage detection, and there's no lightning strike risk than other systems. And there is a better real-time data for predictive maintenance. The pilot that we envision together with EDP is the following: is that you at EDP, you select a wind farm with 5 wind turbines. And for 2 of those wind turbines, you don't tell us what the blade damage is. We will conduct an interior inspection together. We will update our installation manual and instructions specifically for the turbine that you have selected. And then the usual EDP maintenance crew will install the Tarucca system. We will collect the data, we will analyze it, we'll combine it with other available data. At a certain moment, EDP will organize that the blades with damage are repaired. We continue our collection, we will share and discuss the progress and the findings. And in the end, we will, as Tarucca, we will tell you what our conclusions is on the blade damage from the 2 wind turbines where you didn't tell us what the blade damage was. We can agree upon the pilot scope in the 2nd quarter. We can do the installation in the 3rd quarter of this year, and the total pilot can be concluded by the 3rd quarter next year. At that moment, as EDP, you're in a very good go, no-go position to decide if you want to do a further rollout. Total cost for the pilot is €133,000, plus the time for 2 ADP blade engineers for 1 to 1.5 days per turbine and the Tarucca travel. And I think we all can agree that, say, that amount of cost is peanuts compared to what real blade damage is costing. As said earlier, with this pilot, EDP puts itself in a perfect position to take a well-informed go, no-go decision for a further rollout. The risks that are there, they can all be mitigated. Weather is the most difficult, but the timing is not that tight. As Tarucca, we are based out of the Netherlands. We did our first research pilot installation in a V90 in the Eemshaven in the Netherlands in July of last year. We are a member of various research and pilot consortia here in the Netherlands, together with Shell, Vattenfall, Eneco, TNO, TU Delft. We have an experienced management team. Overall, I would say that with the next step towards condition monitoring and predictive maintenance of blades and a very positive business case, the next step is that EDP invites Tarucca for the bootcamp in Singapore, and then the rest will follow. Why EDP and Tarucca? I would say we both choose Earth. That's our drive, and we both are changing tomorrow now. We both know that we have to act now. Thank you for your time, and I welcome any question.
Thank you, Hans. Right on time. Thank you. So now let's go for Q&A. Who has questions?
Can I stop sharing, by the way?
Yeah.
So, hi Hans, thank you for your presentation. How many Tarucca sensors do you need to install on the wind turbines to have accurate results?
It's a good question. At this moment in our installation, we have at 3 locations per blade. We have sensors. We're still optimizing this. So to be honest, we don't know yet which one we can leave away for the best results. But we envision that in our pilots initially, we over-dimension so that we know which data from which sensors we can take out. And the sensors are installed till about 1/3 in the blade measured from the root. but we put them
Okay.
at this moment at 3 locations.
Per blade.
Per blade, yes.
Yeah. Okay.
Who's next?
Just one quick question, and thank you for your presentation, Hans. So you mentioned you had 1 pallet last year. Do you have any other projects in the pipeline?
Yeah, we have projects preparing at this moment with Shell, Eneco, and Vattenfall, with all 3.
Okay, perfect.
So we haven't installed yet, but we are preparing for them at this moment. We are selecting the turbines together with them.
Okay, good. And what would you say your TRL level is?
It depends on if you look at it from a hardware point of view or from a total system point of view. So from a hardware point of view, we're probably on TRL level 6, total system point of view between 5 and 6. Hardware is a little bit more because it is probably at 7. But total system point of view is between the 5 and the 6.
Okay. Yeah, it makes sense. Thank you, Hans.
Just one last quick question. I'm not sure if you mentioned that, but is there any preference regarding the location of the wind farms in the pilot project with EDP?
Not really. We can do both onshore and offshore. Europe is a little bit easier for us because it's closer by in the same time zone. But we are an international team. We have been in many different countries, so I'm looking forward to go back to Singapore. I lived there for a while.
Okay.
No
Thank
pressure.
you.
Sorry.
Okay, someone else?
Sorry, I remember now. You mentioned you operate in offshore wind as well?
To be honest, we don't have the wind turbines that we are selecting at this moment with Eneco, Vattenfall, and Shell. They will be offshore.
Okay.
But the one that we have at this moment, the V90, it's in the Eemshaven. It's as close offshore as you can get onshore.
Okay, perfect. Thank you.
Any last question? No. Okay. If you have questions even after this that you remember, just write in the chat and we'll forward them. Okay, so Hans and Hernani, thanks a lot. Thank you for your presentation, and we'll let you know the results in the next few weeks.
Okay, thank you for your time.
Thank you.
Bye-bye.
Bye.
Thank you. Bye. Okay. Next, we have Fibersail with Carlos and Sander. John, you can let them in. Hi, Carlos.
Hello, good afternoon.
So, okay. Is Sander joining? He's here. Okay.
Yes.
Yeah, I'm
Yeah.
here.
Okay. Hi, welcome. We are here with DDP, and we're ready to hear your pitch. So I don't know who's gonna share, but yeah, feel free to share your screen, and then you have 4 minutes to pitch.
Okay.
Yeah, we can see.
Yeah, you see the screen? Fantastic. William Thomson, a famous British mathematician, once said, "If you cannot measure it, you cannot improve it." This definitely accounts for wind turbine blades. These huge composite structures harness the wind energy and are critical to our energy transition. However, we still don't know how these blades actually behave in operational conditions. Fibersail measures the deflection of the blades and provides the owner extension of lifetime, improvement of performance, and lowering of the O&M cost. Unplanned maintenance cost has been a huge cost driver in the wind energy sector. $8 billion has been spent in 2019 alone, basically all focused on repairing and replacing drivetrains and blades. And the problems are only growing. Research in the field have shown that large rotors, cracks in large rotors, propagate much faster than smaller rotors. A crack occurring in year 1 has a 98% chance that it propagates to critical sizes in year 3. Current inspection methods only focus on the outside of the blade, whereby drones or visual inspections are used. However, these damages, leading edge erosion, trailing edge erosion, are not critical for blade failures. What is critical are the inside of the blade, where the primary structure holds the blade together. If cracks occur there, it can quickly propagate to critical size. Being able to monitor and detect these damages at an early stage is what Fibersail can do. And preventing blade failures is what the result is. How do we do it? We have a composite beam with fiber optic arrays inside. We install this beam inside the blade from the root to the tip, and we measure the flap and edgewise deflection. We basically create a digital twin of the blade. And with that deflection, we're able to create outputs and value to the customer. First, the output is a pitch and yaw optimization, which results in an AEP improvement. The second route is an early damage detection, which reduces the O&M cost and provides the owner condition-based maintenance instead of the usual done preventive maintenance. And thirdly, there's a lifetime calculation possible whereby the owner can continue operating safely past its design life. We use this data and present this in a dashboard, and the customer can actually access this dashboard. We also utilize customer-based dashboards if that's a better fit. We have several pilot projects running across Europe, 5 pilot projects. And we get a lot of nice results from it already. This is an example of one of the results, whereby we detected an erroneous pitch operation. You can see from this graph that for the same flapwise deflection, when we corrected for the pitch, so we moved up on the power curve. And this already improved the AEP by 1%. The system is sensible to half degree of pitch alignment. We have much more need for more turbines to be outfitted with our sensors to feed our algorithms with deflection data. And for that, we would like EDP to join us in a demonstrator project. This demonstrator would consist of 3 large onshore turbines and consist of 12 months of data collection, whereby we already optimize on the performance and on the condition monitoring during those 12 months. The initial investment will be 150,000 euros, and the total benefit already based on a 7 megawatt turbine, around 55,000, consisting of yield improvement and condition monitoring benefits. The payback period is 3 years. We hope that this will entice EDP to join us in a demonstration. Thank you very much.
Thanks a lot, Sander, and thank you for respecting the time. Okay, so now let's go to Q&A. Who has questions?
Hi, Sander. Thank you for your presentation.
Yeah.
Is there any limitation regarding the size of the turbines or even the model or the provider?
No, they're not. The nice thing is that the bigger the blade gets, the higher the value that the customer gains from it. So the sensor itself is installed inside the blade, and it can be in sizes of from, let's say, 40, 50 meters onwards to, well, unlimited, basically.
Okay, thank you.
Yeah.
Felipe, go ahead.
First question, on the pilots that you have performed so far, did you get any third-party validation, meaning some certified institutes following the works and validating those works?
Carlos, this is a question for you, I guess.
Yes, I can step in. Hi, Filipa.
Hi, Carlos.
So also regarding that, we are doing some pilots. We are getting out the demonstrator, and we are working actively with a certification body to certify the hardware itself, the sensor itself, but all the way to the installation and all the way to developer positions. So it's something that is not yet available, but we are working on that.
Okay, so it's an ongoing process.
Exactly, but again, the more data we have, the more statistical certainty also the certification body gets. That's what we are working now with them.
Okay. And regarding the business model, can you elaborate a little bit on that? So what's the business model that you are envisioning for this kind of solution?
Yeah, so basically the business model is focused on the hardware sell, including a SaaS fee, let's say monthly or a yearly fee for value proposition developments. So basically we see, as from the presentation, we have a couple of value propositions like yield improvement, early damage detection, but also remaining lifetime calculation. That obviously requires engineering capacity. And we would like to charge a monthly or a yearly fee for each of the value propositions for that. Yeah.
Okay. Okay, thank you. And last question from my side. Is this something that can be installed when the turbine is already installed, or do you need to
Yes.
put this from the manufacturer, system
Yeah,
manufacturer?
good question. Basically, all the pilot projects that we're currently running are retrofit solution. But obviously, so that's the let's say for the short term the right approach for us to work with developers and owners like EDP to retrofit these solutions. In the near future, we hope to integrate this into the OEM's standard, let's say. Yeah. But to
And
get
have
to that
you
stage,
talked with OEMs for that, or
yeah.
have you already talked with them?
Yeah, for sure. Yeah. So one of the pilot projects is directly with one of the OEMs. Yeah.
Okay.
Yeah.
Okay, thank you.
Okay,
And
last question from Lisandro.
Can I add just a small detail, Filipa, on that? As said, the more data we get from the field with deployments with owners like EDP, the more data we have to convince the OEMs to integrate the technology in the product. So you can gain today from this, but you will also gain in the future with the technology integration in the product that you buy, basically.
Okay.
Yeah.
Last very quick question, Lisandro. Go ahead.
Yeah, you said that you're looking for a 12-month pilot project. So the question is, in your previous test, how long have you been with this test installed in the different windmills?
Yeah, it depends, of course. I think in several pilot projects, one is currently installed from March onwards, so almost a year. We see that 12 months data collection period fits well because you have all the seasons taken care of that. And we see a lot of seasonality also in the blade deflection. So because winds are different in the winter than in summer, for instance. So 12 months data collection period gives us the best data set possible. And that's where the 12 months come from.
Yeah, and your previous pilots, how long have you been with them?
We have several pilots. So I think, Carlos, when did we start our first pilot? 2020 or something? Or?
Yes, I can step in. So depends again on the customer. Of course, an OEM has different needs, and we are testing a lot with them, also some algorithm improvements, and then with the end customers. Depends really on what is the demonstrator that the company needs, and what is also the potential for commercial deployment. But we have systems running out there for, I think, 2-3 years right now.
And did you have any issue regarding the installation of the sensors so far?
Well, yes and no. So we had issues in the past. Of course, the first ones were not were not easy. We now have a system that works. We have a system deployed. We also have cooperation with OEMs. We always need to have this validation. Of course, depends on how you have the operation maintenance contracts and how you can make this work. Well, we have basically pilots with all major Western wind turbine manufacturers or with those turbines, and we have not felt an issue doing this, of course.
Okay, thanks.
Thank you for your presentation and the questions. We ran out of time, so yeah, thanks a lot, and we'll get back with the results in the next few weeks. Okay.
Thank you, Margarita.
Have a great day.
Thank you. Bye-bye.
Okay. Next, we have Reblade with Frank. Okay. Well, you can let Frank in. Hi, Frank.
Hi there.
Hello, welcome.
Thank you.
We are here with EDP and we are ready to hear your pitch. So go ahead and share your screen, and you have 4 minutes, so you can start anytime.
Thank you very much. All right, you all know my name. So I'll just say that we're a startup, 3.5 years old, doing a flying automated repair drone. And the problem that we are solving is very costly and pertains to the maintenance of wind turbines, where the blades are becoming a very costly problem, bubbling up now that some of the issues with the VTG, the top, the nacelle has been solved. So all blades have this erosion issue where they over time.
Sorry to interrupt. I cannot see your screen.
Oh, you cannot?
Are you? No.
I did press it. All right, let's try again. Sorry about that. That's not very helpful. All right, let me start over. I'll just speed up the talking.
Okay.
I'll be faster, don't worry. So yeah, anyway. We're doing we're solving a problem that's very costly with the wind turbines, a very big market and costly problem. And blades is particularly costly and becoming the most dominant problem since they all are exposed to wear and tear and different types of damages, where erosion is the most costly one. It's currently handled manually by rope access technicians, and they're in demand. And the shortage is crucial and growing. So our competitors are trying to supplement that approach, but have introduced technology that works in the same way. It can't be used offshore, it's too heavy, it operates at the same speed, and it also requires specialists. So in summary, the current state of art is that it takes 4.5 days to repair 3 blades, where we bring a tech-driven solution that takes only 4.5 hours. And the drone is designed and developed for being used on and offshore. What is very important as well, it is usable by semi-skilled, normal, regular service technicians. We have a solution that fits energy companies. We're on contract for the first 12 drones, and we have an energy company paying just to have priority access. But what is most important, I think, is to understand that this technology does disrupt, and that's why we've had 3 acquisition attempts by service companies and OEMs, because they have contracts with the energy companies such as EDP for sometimes 5 or even 10 years based on the cost for manual repairs. And once we offer them the ability to do it 6 times faster, they want to reap the profits and not let it benefit the energy companies and the consumers. So that's why we are focusing on energy companies instead of service companies, because we offer a way to increase energy production.
I can't hear. Frank? Is it only me? No.
It looks like he disconnected. Frank, can you hear us? Yeah, he disconnected.
Okay, he's back. Frank, are you there?
I hope I'm back.
Yeah,
I'm not.
you're back. Yeah.
I'm not sure what
You
happened.
are.
I'm not
Yeah,
sure
yeah.
what happened. This is going really well. I apologize. I'll speed up even more. So yeah, this is let's go to the team. This is the team. We're currently seven people. Sorry. We are growing to 13 by June this year. We've just closed with the lead investors, so we have money to scale the team and the manufacturing capabilities. All right. I hope that's fair use of time.
Thanks, Frank. I know that is lots of pressure.
Yeah, I'm sorry.
No, don't be. So let's go for Q&A. Who here has questions, Frank?
No.
So, hi, Frank. Thank
Hello.
you for your presentation. Can you please elaborate more about the pilot project that you are proposing with EDP?
Yeah, so we're introducing two products. The first works in collaboration with the existing rope access people, where we handle the first and the last part of the process, where the next product handles everything on its own. So it's a gradual process. So we would like to start in late 24 with getting some of your technicians to use our technology to learn how to fly it, and then take some of the process that they currently do, and once they're familiar, move into the product that handles the entire process.
Okay, and is there any limitation regarding the geography or the location of our assets?
Not necessarily. We are based in Northern Europe, in Denmark, in the Nordics ourselves. So Europe is preferable, but I'm going to the US for 2 weeks in March to start our introductions over there. So we are available, not globally, but internationally if the project is right.
Okay, thank you.
Yeah.
Okay, Lisandro, go ahead.
Hi, Frank. I was wondering, first of all, I don't know if you mentioned this, but what type of damages you are currently going for with the drone?
Yeah, so you separate the blade damages into 5 levels or categories, Cat 1 to 5, and we're targeting from the start category 1 to 3, which is where it's preventive maintenance. Once you move into 4 and especially 5, of course, you have eaten into the laminate to the structural integrity, where you require the usage of a special putty. You typically do that manually, but some of the suppliers are looking into robotic solutions, and our technology will be able to use that once it's commercially available.
Okay, but you focus on leading edge?
Yeah, we are focused on leading edge because it's the most costly.
Okay, perfect. What are you doing all the process? I mean, sanding, cleaning, filling, putting the filling up. I mean, the whole process you can do with the drone?
Yeah, so you basically trim it down to 3 processes with some sub processes, as you just said. So there's the grinding or the sanding, then there's the cleaning or the prepping, and then there's the coating. So the first model that we would like to pilot is handling the first, the grinding or sanding, and the last. And that procedure was developed by an energy company because they wanted us to, since we were a small team, to come to market faster. So instead of waiting for us to have all 3 processes, they actually suggested this hybrid version where they send up people to do prep, the cleaning of the blade before we coat it. So that's why we came to market a year earlier.
Okay, good. So how much time do you need for going for a whole process with a leading edge?
For the model that we are using in 9 hours for all 3 blades, and once we have the remaining module for the cleaning, where we don't need people up in the turbine, we can do it in 4.5 hours for 3 blades in total.
Okay, thanks, Frank.
Sure.
Okay, last very quick question from Juan.
Yeah, hi Frank.
Hi.
I have one question regarding the drone. Do you cover the whole leading edge?
Yeah, so you typically do like around 7 to 10 meters from the tip. You don't cover an entire blade length because the damages are at the tip. That's where the rotational speed is higher, up to 350 to almost 400 kilometers. So that's where the grinding, the sanding, it's like sandblasting the turbine blades. So the leading edge is from the tip and 7 to 10 meters. You don't do it on down to the root.
Okay, perfect. Thank you.
Sure.
Okay, that's it. Thanks a lot for your presentation, Frank. We'll let you know the results in the next few weeks. And have a great day.
All right, you too. Bye.
Thank you. Okay, so now let's just do a very short break, like just 3 minutes, okay? Because we need to be back for the next one. Yeah, so 3 minutes. We'll be right back. Okay, we are back. Everyone back? Okay. Next. Okay. Next, we're going to have Jonathan from Safety Bolt. João, you can let him in. Hi, Jonathan.
Hi, everyone. Good to see you.
Well,
Hope you got to stretch your legs.
yeah, a bit.
Yeah.
Welcome. We are
It was a
here.
quick one.
Yeah, I can see your screen. So we are here with DDP and we are ready to hear your pitch. So you have 4 minutes for it, and then we go to Q&A. So go ahead.
Absolutely. Good to be here. I'm Jonathan, and I'm presenting for Safety Bolt, and we're making sensors for bolts to understand their strain change. So when we understand how the strain is changing in a bolt, we also understand how it is changing in an entire infrastructure project. So if you have a bridge, a tunnel, or a wind energy plant, we can pick up that precise change. And this has earned us a lot of attention from several industries, as you can see. And when we present our technology to these companies, they say that it's the best they have seen over the last 5 years for this application. And in the wind industry specifically, people have been trying 15 different technologies, but believe in Safety Bolt the most. And these are technology partners then supplying such sensors to Vestas as an example. That makes us very happy. And if you wonder why people have been trying for such a long time, spending a lot of resources, it's because it's a huge purpose. People are dying in mines. People are spending billions in vain on infrastructure. And in the green energy transition, we see a huge spend on manual checkups in offshore wind energy. This spends a lot of extra time and money that is not used in the best way possible, but it also gives us very limited data back. A wind energy plant, as you may know, has a lifetime of 20 years that is stipulated by the law, unless you can prove that it has a structural integrity that meets certain requirements. We believe that we can supply that data to extend the lifetime another 10 years. And that's why we already have Vestas and other asking us for a pilot. This works quite easily, that we can apply this sensor on an existing bolt or on a new bolt, which makes application very easy. You put it on, we leave it there for 5 to 10 years. We push the data to a central unit so that we can give you a notification on your cell phone. But even more importantly, we collect this data to do predictive maintenance analysis, to give you the insights of how long your wind energy plant will last, but also how you can improve it for it to last way longer. That's why we already have several pilot requests from industry leaders within a lot of different industries. Notably here, we have Vestas, of course, but then also Bosch have paid already for pilots where we checked off all the requirements that they asked for. And we were actually the only project to be taken forward when Bosch themselves closed down their own innovation departments. So we today have 2 different asks, and this is because we already have the technology partners needed to kind of go ahead. We have a very clear path. We have huge $20 billion companies asking us for doing pilots, but also commercially engaging in exclusivity. So at the moment, we have too many partners that we can actually engage with, and so we're looking for the right ones. We believe, therefore, it's very timely to go into this program with you guys, because in just a few months, we will close down that window and go with one or a few partners specifically. And we'll do that with some of the funding that we're raising here in a convertible round closing in March and April, where we already have dedicated capital applied. So with that, I'll be happy to take your questions, whatever that may be.
Thanks a lot, Jonathan.
Hey, Jonathan. Thank you for your presentation. My name is Lorenzo for Motion Winds, and I'm curious on seeing like how would you see a pilot in this case for applicable for offshore wind foundations, so bolts in the foundations. Do you have an idea?
We actually, yeah, sure. I have a very specific idea actually within talking to industry leaders in this field for specific pilots exactly like that, where we've already been invited actually 8 months back to a testing site to begin with, where some of these large industry partners already have testing grounds, let's say onshore, where that would be the first testing phase of the pilot, where then the second one would be fully deployed out in the field, let's say, in offshore, where these sensors would be put up in both the foundation of the wind energy plant, but also in the rotor, picking up slight changes then when wind waves and deterioration of the materials and so on is impacting the structural integrity of the entire, the entire plant, but then also as a proxy, these bolts. So that's what we would like to pick up for both the entire structure of the plant then, but also the rotor itself.
And that's what you're planning with Vestas, or for Vestas is onshore currently?
Exactly. Vestas has been confidentially in this group, been asking for that very specifically. I'm having several calls with them. What we are interested in is we're a small company with a big technology. So we also have a lot of other partners, both wanting to pay us money for development in certain areas. So what we're doing now is picking and choosing between these large corporates to say, which do we want to go ahead with?
Okay, thank you very much, Jonathan.
Sure.
Who else has questions?
There's no stupid questions here. I'm a dumb consultant myself, so I'm kind of pretending to know the technology, but please challenge me.
Jonathan, thank you very much for your pitch. This is a very easy question. Just trying to understand a bit better on the technology development of your solution. Where do you see yourself in terms of TRL, and what future technology? What is your future technology roadmap?
Yeah, it's a great question. I forgot to say that this is also a product of the RISE Research Institute of Sweden that have 2,000 scientists who over several years developed this as a patent, where we took over the ownership of that patent. So this is patented all over the world. And that really helps us obviously in scaling this up. We have a very close collaboration with RISE still. And I just spoke to them hours ago on new patents that they have already filed that is very close to what we're doing now that could complement, where we have then deals to be able to take over those patents that would also prolong our own IP strategy, let's say. So we have quite a clear plan down, and if you have more time later, I can go into depth of this. But all of this, we have great partners legally who have been going through the patents, looking at freedom to operate, etc. Does that answer it? I'll try to be quick.
Yeah, in terms of the patents, yeah, but in terms of the solution you're offering right now, so it's ready for commercial rollout, right?
Yeah. So sorry, we're at TRL 5 exactly, and doing these. Yeah. So the prototypes for the specific companies, we do not want to do an off-the-shelf completely. We want to understand the very specific specifications from, let's say, Vestas, and then develop to their needs, because that in itself is a huge volume. And then with small alterations, we can also do this to other industries or other industry players. It is worth to say that we're a hardware provider, but we want to move towards becoming the strain data leader in the world. Also using, of course, AI, but when analyzing this data, creating digital twins and be able to then prolong the lifetime of these structures that we believe holds like $1 billion value.
Okay, very clear. Thank you.
Okay, now last question for Felipe, very quick.
Two questions very quick. First one is, this is a granted patent or still pending?
No, it's a fully executed patent that is alive with freedom to operate in large parts of the world, including China, Japan, Korea, large parts of Europe and US.
Okay. And second question very quickly, not clear for me if you have already some pilots in place or if you are still looking for pilots, for someone to pilot.
We have piloted a couple of paid pilots with Bosch that is already confirmed, where we met all the specifications. For the next round of pilots, then we have already requested pilots by, for example, these companies that I showed, including Vestas, that are very keen on getting this running. What we are doing is choosing the right partner with the best business case, as well as the best technical application, for us to dedicate our time where it really matters the most. Hence, I think that the program and the timing here could work really well for that reason.
Okay, thank you.
Okay. Thank you, Jonathan, for your presentation. We'll let you know the results in the next few weeks. Okay. Thank
Perfect.
you.
Looking forward. Take care. Bye-bye.
Bye. Okay, so next we have Spoor AI. We have just Cinti presenting. So, well, you can. Hi.
Hi.
Okay, can you hear me?
Yes, can you hear me?
Yeah. Okay. Yeah. Welcome, Jacinti. We are here with EDP, and we are ready to hear your pitch. So go ahead. You can share your screen, and you have 4 minutes to pitch.
Yes. Just share.
Yeah, we can see it.
Okay, great. Thanks, everyone. So I am Jacinth, and I will present our proposal to you today. So at Spoor, we enable nature and industry to coexist. And how do we do that? Basically by installing cameras on onshore and offshore wind turbines, and we monitor bird activity and wildlife. And that enables developers to de-risk, safeguard, and reduce the cost by providing accurate data on bird life. So as you know, installed wind capacity needs to increase tremendously in order to reach the clean energy targets that we have in this world. However, there are a lot of constraints that are causing issues. One of them being the bottleneck that is bird and wildlife. That is, a lot of projects are delayed, even canceled, due to regulations that are put in place. And very often, those regulations are simply due to the fact that there is a lack of accurate data. This is very expensive, both for you as a developer and also for the industry. And the current solutions that we have on the market are not adequate, and they don't provide a solution. They are labor intensive, human error can occur, and this leads to even longer delays. And this is where Spoor comes into place. So with our accurate data and scalable solution, we can detect bird with our AI continuously. We can extract data such as bird count, collision, species ID, or even flight height. And this is how the product works. So as soon as the bird comes into the field of view, the AI will start tracking that bird. This will also work for a flock of birds, and it will work onshore. It will collect data on that bird until it leaves. And once it's been collected, that data can be used towards regulators, towards consenting, EIA, towards recommissioning of new wind farms. Some of our use cases. We have trialed at Aberdeen Bay with Vattenfall and BTO. We partner with research bodies to ensure that this data is also valuable for regulators. We have also partnered with Fugro to test the first floating LiDAR equipped with camera all the way 140 kilometers offshore. And that enables us to have data during the pre-construction as well. So now for the pilot proposal. We want to do with you on an existing wind farm a species-specific real-time detection. That means that we want to test the data on site with edge computer. And that will enable us to gather information specifically on those species. We will be able to see what is the difference between X bird and Y bird. Are they more likely to collide? Why? And under which condition? So all those behaviors can then be used towards regulators. This is also valuable because it is the first step towards hopefully avoiding curtailment or reducing curtailment as much as possible and showcasing that it can be done on a dynamic way, which means turbines per turbine. It also de-risks and accelerates data decision-making since we base the decisions on specific data. And finally, it is cost-effective and safe as we don't need to have someone on site physically to monitor the cameras. Now for a call of action, we want to work together to find a wind farm where we can install those cameras and start monitoring in real time. And by investing in this pilot today, EDP will ensure that you get data and all of your assets can be future-proof for any bird impact that there might be. Thank you.
Thanks for the presentation. Yeah. Yeah. So now let's go for Q&A.
Yep. And I'm joined by Ask, who is our CEO.
Welcome. Leonardo, go ahead.
Hi, Zin. Thank you for your presentation. So if I understood correctly, your solution only identifies the birds, but there's no action posterior to that with that information. So you only give that information to the owner of the asset, but your solution does not act upon the information that it retrieves, correct?
That's not entirely correct. So we can do both. So at the moment, the proposal is gathering the data because we see that's needed in a lot of markets to get leverage to build new projects. We can also scope a project where we do dynamic shutdown based on species and target species. So that's also something we can do. It's not what we proposed there, but that, we're also interested in getting your guys' feedback on what's relevant.
So you would have access to the turbine, let's say, and made it stop when the bird is close and then go again. Okay.
Yeah. So you'll do it on a turbine per turbine level, and then you will do it species specific, so you don't have to shut down for like less valuable birds, I guess, the correct term to use.
Oh, okay. Okay. Yeah, I was wondering why the species of the bird would be so important, but I understand. Okay, and then regarding the TRL and the maturity, let's say, of your solution, you said that you had already some pilots going. So what would be the state of maturity of the solution?
Yeah, so it's different parts of the solution have different TRL levels. So some parts of the solution we are already selling commercially. I think for this proposal with the species specific kind of detection of collisions, I don't really, we should ask. No, I think we're like a TRL 7, 8 or something there.
Okay. And regarding costs, capex and opex, how would you say you are positioning?
Yeah. Well, that one is also very specific on a per project basis. So we don't manufacture the cameras ourselves. So we're very low capex on the hardware. We worked with suppliers for high resolution cameras, which are a few thousand euros per camera. So it really depends on a project. If you install 5 cameras, 10 cameras, 20 camera, and from the software side, it's a subscription basis to get access to the data.
Yes, and you would need 1 camera per turbine, right?
Yeah, if there are more than turbines, 4 megawatt plus, then we need a camera project. Cost efficient way as well. You can buy more expensive cameras that call more turbines, but they're usually a lot more expensive because they're not a commodity at that point.
Okay. One last question from me regarding the pilot with the EDP. Would you or do you have any restriction in terms of geography, or are you able to? Yeah.
No restrictions. I think we also, in some cases, we also tapped into existing CCTV cameras, which makes us very, then it's even easier to go far away. So no restriction from our side.
Okay, thank you.
Vanessa, go ahead.
Hi, Justin. Thank for the presentation. Are you technology agnostic in regards to the cameras? So it's applicable for in this case, I'm speaking of offshore wind application. It's for camera that's already installed, and basically the software would run on the feed from the cameras also.
Yeah. So we are camera agnostic. We need a certain quality on the camera, but we can also work with really poor quality cameras as well. You get less range. But the short answer is yes, and we already have on a floating wind farm tapped into existing CCTV cameras and the data stream from those cameras. Yeah, camera.
But how? Yeah, and how would you? Are you capable to detect the different species with if you're not achieving the highest quality of the cameras, so because many times that offshore conditions are not the best in terms of visibility, the camera quality, and the feed that's broadcast. So there perhaps may be many constraints in achieving that level of detail, right? So that's what I'm thinking of it.
So we can do species identification on really bad cameras in poor conditions. I think that what is suffering with bad cameras is usually the range. And so the area you can cover, but you can still cover a certain area and get species identification in a certain area. I think that's one of the kind of core attributes we have, is that we don't need a lot of data to do a species identification, because we build our own AMLs specifically for that purpose and identifying birds with really, really low quality data.
Okay.
Good question.
Just last very quick question from Felipe. Go ahead.
If we set up a pilot, what would be the KPIs that you are willing to propose?
Yeah, I think there's maybe two ways of looking at it. So I think from our side, we want to understand the kind of how precise we can give the data to you guys, and maybe do collision detection in certain sites, for example, could be valuable. I think the most important KPI is also how you guys leverage the data. So can we create value for you and your business in terms of what you're looking for towards the regulators or towards a new project? So that would be the key one, I guess.
Okay. Thank you.
Okay, that's it. We ran out of time. So thank you for your presentation.
Thank you so much.
Yeah, we'll let you know the results in the next few weeks, okay?
Thank you.
Thank you.
Have a nice day. Bye.
Okay, so next we have RCAM, and we have Jason, Gabriel, and Mason joining. Okay. Hello.
Hello.
Hi, all. I don't know who's going to present. Welcome. We are here with EDP, and we're ready to hear your pitch. So I don't know which one of you is going to share the presentation, but yeah, feel free to start. You have 4 minutes for the pitch.
Thank you. Hello, everyone, and thank you again for this opportunity. At RCAM Technologies, our mission is to pioneer automated construction methods to manufacture and deploy a portfolio of next-generation, nature-inclusive clean energy products. My name is Mason Bell. I'm a civil engineer by education and leading our anchor portfolio. Our growing team of experts has experience across 3D concrete printing, engineering, material science, and renewable energy with a proven track record in executing grant-funded R&D projects alongside leading global entities. Projected to be a $54 billion market by 2032, floating solar offers a promising avenue for clean energy deployments. However, the traditional approach to anchoring presents significant inefficiencies. Each project demands custom-designed anchors, leading to suboptimal design, manufacturing, and installation. This fragmented process results in increased costs, extended timelines, and substantial material wastage without a dedicated solution to streamline operations. As EDP looks to expand its floating solar footprint, the need for a standardized, environmentally friendly, and cost-effective anchoring solution is critical for your commitment to be 100% green by 2030. To address these critical pain points, we've developed a patented turnkey gravity anchoring system. Comprised of a 3D concrete printed shell filled with a ballast material, each anchor is precisely scaled and digitally designed, adapting to varying loads, angles, and soils. This results in an optimized anchor design for each anchoring point, reducing cost and carbon emissions by minimizing material inefficiencies and incorporating low-cost and locally sourced materials. In addition, the design flexibility provided by 3D concrete printing allows for the incorporation of textures, materials, and geometries which promote biodiversity net gain. RCAM Technologies proposes to collaborate with EDP in a groundbreaking pilot, the first field demonstration of our technology. We propose to launch a pilot at EDP's floating solar project at the Alcueva Reservoir to design, manufacture, and install one of RCAM's gravity anchors as a replacement to one of the existing anchors. This objective is to showcase the enhanced efficiency, environmental benefits, and cost savings that our solution offers, establishing benchmarks for future installations and accelerating its adoption. From EDP, we're seeking your expertise to ensure regulatory compliance and integration with the existing system, logistical support, access to the Alcueva site, and the use of anchor handling vessels to install anchor. The pilot includes 3 phases. In phase 1, we'll select an anchor to replace, gather site-specific data, obtain necessary permits, and perform a detailed site-specific design of RCAM's gravity anchor. In phase 2, we will fabricate, transport, and install the gravity anchor into the water, followed by a subsequent verification test to ensure the anchor meets its design specifications. And finally, in phase 3, we will integrate the anchor into the existing mooring system of the floating solar array, where it will be subject to continuous operational condition for the remainder of its life. With the primary benefit being providing EDP with lower cost floating solar installations, there are several mutual benefits to this pilot. Elevating the technology readiness level of our gravity anchor to 7 is an essential milestone towards its development and would validate its commercial feasibility. This project also represents a stride towards meeting EDP's green energy targets, addressing both the deployment and emerging technologies challenges. Through this pilot, RCAM and EDP will not only validate groundbreaking technology, but also reinforce our shared vision for an accelerated and more sustainable energy landscape. I look forward to the opportunity to see and work with you all in Singapore, which happens to be one of the world's leading markets for floating solar. Thank you very much for your time.
Thanks a lot for the presentation, Mason, and thanks for respecting the time. So now let's go for Q&A. Who wants to start?
Hi, hello. Diokuler from Generation. I saw that your approach is interesting, but I think that today at the call there is no one from the floating engineering, and I would like to do a suggestion. Alcueva is mandatory for some reasons, or for instance, you could try to do it in the Alto Rabagão, because at Alto Rabagão we have a test bed for floating technologies.
Yeah, that works perfect. We're looking for really any opportunity to get it into operational conditions, so some sort of field demonstration. Alcueva was just the best one we could find online.
Okay, and about the substitution of the anchor, do you have any track record replacing existing anchors or not?
We don't have a track record existing anchors yet. We have a track record in non-dilutive grant funding. We've done numerous projects with federal and grant state agencies doing research and development of these technologies. And so the next essential phase for us is getting one of these anchors installed in operation.
Okay, thank you.
Go ahead.
Hi, Mason. Have you already performed some certification tests, some load tests, durability, and so on and so forth?
We're currently performing a SBIR program with the Department of Energy, where phase 2 will be doing full-scale structural testing in the laboratory environment of the PADI connection. So that's the next essential phase in the development of the technology. And this pilot would be following that, so after laboratory testing. So we would have load verification testing of the structure.
So when do you expect, to close these certification tests?
So the phase 1 of the project finalizes this summer, and phase 2 would commence in this fall as well.
Okay. Okay, thank you.
Mason, I wanted to expand on that answer. We have a portfolio of products, and this is our flagship product. This will be our first revenue opportunity. We've been working on 3D concrete printed solutions for things like wind turbine towers, offshore foundations, offshore anchors, for offshore wind. And as part of that process, we have done in the laboratory structural testing of 3D concrete printed components. And we also have additional funding beyond what Mason mentioned. This project starts next month to work with DNV to certify the materials we need for these 3D concrete printed projects for marine use, is what I would say. So we have the funding, but it is still an earlier stage technology. What we don't have is a place to test.
Okay, thank you for adding that information. And one last question that I have. This 3D printing, where is it performed? So can you perform this in the same place where you intend to install? Or the idea is to transport the...
It's going to be project dependent, depending on how many anchors you're installing. But 3D concrete printing is a rapidly advancing field, so there's commercially available printers in most regions around the world now.
Okay.
So the idea would be to use localized manufacturing so that you can reduce carbon emissions of transportation of these anchors even more, as well as using locally sourced materials.
Okay, thank you.
Hi.
Okay, question from Luis. Yeah.
Yes. Hi, this is Luis Santos. What's your expected unit cost for every anchoring piece in beyond 2026? That is when you plan to reach tier 9.
Each anchor is individually sized, so they have a different amount of material per anchor. So each unit comes in at a different price. But I'm going to refer to Gabe, who is also on the line, who has a better understanding of the per unit price of just the 3D concrete printed material.
Okay.
Yeah, so on the cost basis, basically we look at dollars per ton of holding capacity. And based on our comparisons that we've done between a normal concrete block and our 3D printed concrete, because we're saving so much of this mass and being able to replace it with the aggregate, we project a 65% reduction of the amount of concrete, and that translates to about a 50% reduction in the cost of the overall component.
Mm-hmm. And what's the rated power of the printer in terms of kilowatts?
Power of the printer. So we have a varying printing solution going from a robot arm up to a big gantry that we're installing right now. And they are basically 480 volts, kilowatts. I don't know off the top of my head, but it's about 30 amps, I believe, of 480 power.
And it's worth mentioning we have run these printers and the mixing equipment, which also requires power. We've run that connected to the grid in our 3D printing facility in the Port of Los Angeles. We've also run that from a diesel generator in the Port of Los Angeles while they were doing construction and we didn't have grid connected power.
Okay, thank you.
Okay, thank you all. Thanks for your presentation and for answering the questions. We'll get back with the results in the next few weeks. Okay, so thanks.
Thank you very much.
Thank you.
Bye-bye.
Bye.
Bye.
Yeah. Okay. So almost at the end. Now we're gonna have PipeIn, and Alessandro is gonna be presenting. Yeah, Alessandro, hi.
Hello, hi. Hi.
Well,
Hi, everyone.
We are here with EDP and we're ready to hear your pitch. So go ahead and share your screen. You can start presenting. You have 4 minutes.
Yes, tell me if you can see my screen correctly.
I can.
Okay. Okay, perfect. So, hi everyone. My name is Alessandro Minori. I'm the CEO and co-founder at PipeIn. Hydropower is the largest renewable energy source, and it accounts for more than 60% of the overall renewable electricity production. But there is a huge aging problem, especially in Europe, where around 50% of all the hydropower plants are more than 50 years old. And with age come troubles, especially when hydropower maintenance data relevant to penstocks and tunnels are hard to get, hard to manage, and hard to use. And this is a problem because chaotic or missing informations in this industry can lead to long out-of-service periods, waste of natural resources, and environmental disasters. Of course, new technologies are emerging, like drones or standards ROVs, but they can provide a significant high-quality certified set of data. And this is why they fail in helping operation and maintenance managers to increase the plant's efficiency, optimize the production, and ensure the safety of the plants. This is why we are developing a solution composed of 2 parts. There is a submersible robot that is inserted inside inside penstocks, pipelines, or tunnels, and allows an inspection from the inside, linked with a predictive software that allows plant managers to switch from the current preventive approach to a more efficient predictive one. How it works? Basically, we aggregate the data coming from the inspections with the data that are already owned by our customers. For instance, the geometric features of the pipelines or the nominal pressure. We create a shared data set, we process it, and at the end of the day, we provide a final report containing the risk of failure and the residual life of each inspected pipeline. Thanks to our approach, you can save up to 90% in the pipeline inspection times and up to 10 million euros for each year for each gigawatt of installed capacity. And you can do this with the fully digitalized approach, obtaining a certified set of data, and of course, while ensuring the safety of the personnel. The feasibility of our value proposition was already proven on the field. Here you can see, for instance, the results of a pilot project we carried out with Edison, where we inspected 100 meters long penstocks. Today, we are proposing a similar approach, similar process. We are proposing a pilot based on 3 main steps. In the first phase, we are going to discuss with EDP, which are the most suitable plants for these applications, and we are going to identify the most relevant KPIs. After that, we plan to collect all the available maintenance information about these specific plants, and we are going to perform a preliminary statistical analysis that we are going to provide to EDP through our proprietary software platform. And after that, the third phase will include an inspection of all these infrastructures, where we collect the data with our own device. And after that, we are going to compare the data that we collected with the data that are already owned by EDP, and delivering everything in a certified report. The estimated duration of this process is around 8 months, and the type of plants that we can address are reservoir or pumped storage. Moreover, the number of kilometers that we, let's say, we envision for this project is around 5. And at the end of this project, ADP can digitalize parts of its maintenance process in the hydropower, let's say, in the hydropower field, can access to a certified set of inspection data, and can get a comprehensive analysis of the health status of its infrastructures, not only now, but also in the future. The total, let's say, cost for this project is around 50,000 euros from our side. Thank you for the attention, and join us in our mission to bring the hydropower maintenance to the next level. Be predictive, ensure your future. Thank you very much for your time.
Thank you, Alessandro. Thank you for the presentation. So now let's go for the Q&A.
Okay.
Who here have questions? Diego, go ahead.
Hello?
Yeah, I can hear you.
About the asset you want to inspect, do you have some, based on the knowledge of the EDP production hydropower plants, do you have some preferred or best choice hydropower that you want to test, or it's up to EDP production to choose, and you adapt your solution?
Yeah, thank you for the question. Basically, about this, here you can see the, let's say, the tech specs of our device. So, of course, these are our preferred features of plants, of the penstocks or tunnels that we can inspect. So up to, let's say, 1,050 meters that have a maximum pressure of 70 bars. And with the operational pipe diameter comprised between 0.5 and 2.5 meters. This is our preferred, this is our sweet spot, let's say. But since we are aware of the fact that the out of service plan and the maintenance plan, the maintenance planning is, of course, let's say, complicated stuff. It is necessary to talk with ADP to see which are the plans that are available that can eventually fit these specific features, and if not, which are the plans that are available that can be, let's say, inspected with this technology.
Okay.
Okay. Does someone else have questions?
Hi, Alessandro. Thank you for your pitch. So what are the main distinctive features of your solution compared to other or the similar solutions in the market?
Yeah, let me go back here. As I said, the standard methods are teams of specialized workers, as you can see here, that take let's say spot and uneven measurements. The new technologies that are usually used in this industry are flying drones, as you can see here, for confined spaces, or standard ROVs. Basically, we have several distinctive features with respect to this solution, because our technology is fully submersible and can be deployed while the plants are in operation. And also, we can achieve a very long range of, let's say, we have a very long range because typically drones can fly for a few, let's say, tens of meters, and standard ROVs can arrive up to 300 meters, let's say, while we can go up to 1,500, but our technology is 20 kilometers. So we can expect very long tunnels and also very steep, let's say very steep pipelines. And moreover, we have a very specific set of measurement tools that allow us to get to measure the residual thickness of the pipeline wall. And this is something that only with our technology you can achieve.
Okay, thank you.
Okay. Any other last very quick question? Okay, I think that's it. Thanks a lot, Alexander, for the presentation.
Thank you.
Yeah, I'll get back with the results in the next few weeks. And thanks. Have a good day.
Thank you. Thank you very much. Bye. Bye. Bye.
Bye.
Okay.
Hi, everyone.
Hi, Matej. So we have Matej here from Ogre Artificial Intelligence. And Matej, you can start presenting. We are here with EDP, and you have 4 minutes to present. So go ahead.
Okay, so first of all, thanks a lot for having me, and I appreciate the time taken to discuss today. My name is Matej. I'm the CEO of a company called Ogre. Our company has the vocation to do and to produce the best quality forecasts for utility companies. Today, we work in electricity and gas, and hopefully soon enough, we will also be working in water and district heating. So our main goal of the company is to provide the best forecasts, and as such, we have and obviously to address the challenges such as energy transition, such as the renewables adoption, EV adoption, balancing market penalties, and other data quality issues that we see all over the markets. I can tell you that our solution is completely integrated. So we have built multiple use cases for, let's say, for utilities, depending on how many they want. They can either access one solution or multiple. As I mentioned, we are working with the whole energy value chain today. So we are working with the producers of renewable energy. We are working with the suppliers of energy, so very large companies, also with the distribution system operators, and soon TSO as well. Our solutions come under one platform. You can access one or multiple, and they are generation forecast, demand forecast, EV charging stations forecast, and consumer forecasting, which has become more of a challenge recently. We also do technical losses forecast already for about 6 distribution companies, and anomaly detection strictly within, let's say, the consumption data that we find. I will skip a few slides so I don't bore you too much, but how we work usually is we run a pilot, and we're very happy to prove our work basically and the quality of our forecasts. Our engines use AI and machine learning as a base technology in order to provide the service. So we usually go for a pilot phase, which is usually from 1 to 3 months, depending on the appetite of the clients. And then we either go for a subscription or a license, depending on also if the client wants to go OPEX or CAPEX, and they have these kind of requests. Just to go very fast through it, these are some of our credentials, and I can give you a few examples of projects. With Enel, we're working for 3 of their distribution companies. They have altogether about 4 million consumers, and we do technical losses. For CEZ, for example, we are working for a 600 megawatt wind farm. With ENGIE, we are doing about 2 million gas consumers. So this is a gas project. With Verbund, we are working in Austria and Germany, and we are doing the EV charging stations forecast. With E.ON, we are doing, let's say, the forecasting of demand. They have about 3.4 million consumers in the supply business, and the DEI here, which is the biggest electricity company in Greece, we are doing demand forecasting as well for about 4 to 5 million consumers, since they have been losing some market share recently. We always had a top-down strategy. Our platform works very well. I'll be more than happy to show you a bit around how it works if we have the time. And I think this is about it. If you have any questions, I'll be more than happy to answer any of them.
Thanks for the presentation, Matej. So let's go for Q&A.
Sure.
We here have questions.
I can make a question. Yeah, Matej. Thank you for your presentation. So one thing that it was not clear for me when you were presenting the types of forecasts. Do you do forecasts, let's say, for the wind speed and the sun intensity, or the electricity production or energy production?
Yeah. Energy production, energy consumption, and technical losses of distribution companies mainly. As well as prosumers forecasting, which became more of a problem, and the EV charging stations forecasting, basically.
regarding the energy production, is it at the asset level, let's say a turbine, or is it like for the whole park or for a whole region?
Sure. Depending on the data that we find there, we do multiple use cases. So we have use cases where we take data from every turbine, from the metmasts, real-time data from the SCADA servers. And depending on what the AI finds as being more useful, then we use it or we do not. It has happened in the past that using the real-time data from each of the wind farms not to give us good results. It just has happened, basically. But usually we can do either of the use cases. So we use as much data as possible. We feed it into the AI systems, and then the AI decides by itself if it wants to use it or not.
Okay. Regarding pilot with EDP, would you, or are you limited in geography, or do you have any preference in geography?
We have no preference at all. We would like to work in as many places as possible, actually, to be able to prove our worth everywhere. I can tell you that the application is connected to all the data necessary to basically offer the service anywhere, even United States, Australia, wherever it may be. It has all weather data, economic data, holidays, whatever we may need, in order for us to be very specific into where we provide the service. One example would be the United States, which every state has different holidays. It's just an example. So we have data for each and relevant state, for each and relevant place. So we're very happy to have multiple locations for a pilot, definitely.
Okay, thank you.
Thank you.
One question, and thank you for the presentation. How do you handle with data ingestion? So I guess it can depend a bit from use case to use case, but how do you handle it? How dependent are you on integration with our current data sets?
It depends really what the company desires. We can integrate, and we have integrated with a lot of systems, especially at enterprise level, where we have to integrate with ESB systems, with meter data management systems, basically metering systems and everything, SAP for billing. So we've done all these use cases so far. It depends a lot on what you want to do. Usually we take data from an FTP server, we can take it through an API, or basically we can send it to us manually, which is not as favorable, obviously. But usually we like to have real-time data in order for the results to be better, and we can connect to you in any way that you desire, FTP, API, or we make some manual, let's say, process that we can take it out.
Okay, but for a pilot project, let's say, to test the technology, eventually sending you a data set, if we don't want anything like with real-time data, that can work, right?
Of course, it works. So I don't know if the results will be as good, of course, but we can definitely test it. Ideally, we have both. We're more than willing to connect with the data even for a pilot. So more than happy to do that, even if it's an unpaid pilot. We're still very eager to work on it.
Good, thank you.
Sure.
Hi, Matej. What artificial intelligence platform is running below your system?
Basically, to put it in very simple terms, we have a forecast engine factory. What happens is it produces a forecast engine for every problem. Every problem may mean every renewable asset which gets its own forecast engine, or you can imagine a supply business with 1 million consumers, and we have to forecast each and individual one. So what would happen? This forecast engine factory would produce a forecast engine specifically customized for that consumer alone. So it's let's say a process of many Lego pieces which gets put together basically, and it produces the highly customized single forecast engine for that problem. You may think of these Lego pieces as being how do I parse the data? Do I use one model? Do I use an aggregated neural networks with other types of models? It's a very, very complex, let's say, forecast engine factory. I can share some diagrams with you so you can get a high-level picture of how it looks. But basically, it's a forecast engine factory which produces forecast engines specifically dedicated to the problem that it wants to solve. And this means we do not use a champion model, for example, for all high voltage consumers, which happens mostly with our competition. We do not use the same AI models for each individual asset if they're all solar, for example. So it's very highly customized.
But is it based on a commercial platform such as Google AI or TensorFlow?
No. We've built everything internally. It's completely proprietary. My partners have a huge background from the hedge fund industry. They were both quantitative traders. We took the principles from the financial trading systems and we brought them to the energy field.
Okay, thank you.
Okay, that's it. Thanks a lot, Mate, for your presentation. And
Thank you so much.
get back with the results in the next few weeks.
Thank you so much. Thank you for your time. Bye-bye, guys. Bye-bye.
Bye. Okay, and that's it. Thanks a lot for the effort and for staying here and for asking questions until the end. Yeah, today we saw we went through 20 startups, and tomorrow it's the same, but tomorrow it's in the morning. So yeah, have a good rest. And Vasco, I don't know if you want to say something about the file and stuff and such.
No, just thank you, everyone. I think most of you were here for the 20 pitches. So let's have a good rest today, and tomorrow we'll see more pitches. Yeah, please remember the Excel file. I know some of you are already giving your feedback. And yeah, thank you, everyone. See you tomorrow.
Thank you very much. Bye-bye.
Bye-bye.
Thank
See you
you.
tomorrow.
Thank you.
Bye.
Thank you.
Bye-bye.
Bye-bye.
Thank you. Bye.
Não, faz aqui.
Já desisti da operação. Deixa eu saber se não está lá ninguém.